Hi, everyone. Thanks for coming to the Ontario Biodiversity Council's webinar summit. We're just going to wait for a little bit to see if some more people filter in, give them a little bit of time to sign in, and then we can get started. In the interest of keeping us on track and on time, I'm going to get us started. There are still some people filtering in, but we're gonna get started here. So thank you so much for coming and attending our Reducing Threats to Biodiversity webinar as part of the Ontario Biodiversity Council's webinar series. This session is being organized and hosted by myself, Lauren Tonelli. I'm the Resource Management Specialist at the Ontario Federation of Anglers and Hunters, and Colin Casson, who works for the Invasive Species Center. So before we dive into our talks, we're going to have a brief opening message from Steve Hounsell, the chair of the Biodiversity Council, and Elder Dorothy Taylor, a member of Curve Lake First Nations, to really set the scene for this webinar series and the presentations that will follow.
Hello, I am Steve Hounsell, Chair of the Ontario Biodiversity Council. I'd like to welcome all of you to our Ontario Biodiversity Summit, Nature-Based Solutions for the 21st Century. I also want to briefly introduce you to the Ontario Biodiversity Council, now in its 16th year, and the host of this summit. We are a provincial level organization that has come together to achieve the vision and higher order goals and targets that have been set by Ontario's biodiversity strategy, a 10-year strategy that aligns with the Global Strategic Plan for Biological Diversity and its associated IACHI targets. That strategy is a blueprint championed by Council for an ecologically sustainable future for Ontario, its biodiversity, and its people, something we believe is well worth pursuing. We occupy a unique space that links global biodiversity targets with both national efforts and more local implementation efforts. We are working to mainstream biodiversity across all sectors and at all scales in an effort to protect what sustains us. It is embodied in the very membership of Council, with some 38 organizations from a broad constituency of industry and industry associations, conservation and environmental groups, natural heritage institutions, academia, Indigenous organizations, and the provincial government, all united around the theme of protecting what sustains us, our biodiversity. So again, I welcome you to our virtual summit. We hope that the summit will connect people from across Ontario, Canada, and around the world to talk about, celebrate, and most importantly, take action to protect biodiversity and advance nature-based solutions for a more sustainable future for all. You'll be hearing about the alarming state of biodiversity at multiple scales, including from here in Ontario, and the absolute need to bend the curve on biodiversity loss as we pursue a new deal of people living in harmony with nature. It is also an issue that is intertwined both in causation and in solutions with climate change and the pursuit of sustainable development goals, and hence our focus on nature-based solutions. More importantly, you will be hearing about practical solutions to move us towards a more inspired future for all. Remember, the future is all about choices, choices that we collectively make. We will be hosting a number of webinar sessions starting in late May and ending in October. You can find descriptions and outlines of each session on our website, ontariobiodiversitycouncil.ca. We encourage you to register for as many as you can, and yes, they are free. I believe there is something in this summit for just about everyone. We have brought together leading edge thinkers and experts on biodiversity, together with practitioners from many fields to help lead the way towards meaningful, practical, and cost-effective solutions. Let this be the start of an inspired journey to a more sustainable future. We also realize that we need many perspectives, and most notably, Indigenous perspectives, knowledge, and connectedness to nature in order to achieve the transformative change that we so desperately need to address the issues of biodiversity loss and climate change and the pursuit of sustainable development. Now, this was not a small undertaking. It takes a lot of work and organization to pull off such an event. I want to thank our summit planning team and session leads from the Ontario Biodiversity Council. These folks have been working tirelessly for months to bring this summit together. Thank you so much for getting us to where we are. In particular, I want to thank Sarah Rang, Executive Director, and Colin Cassis of the Invasive Species Center for hosting our webinar sessions. It is a huge and much appreciated contribution. And a very special thank you to our sponsors. Sponsors like Ontario Power Generation and Ducks Unlimited Canada, among others. It is because of their collective support that this summit is happening. I also want to respectfully recognize lands where we reside and from where we work. Since time immemorial, the Indigenous peoples were self-reliant and well provided for through their own ingenuity and use of the gifts of the land, living in harmony with the balance of nature. We, the Ontario Biodiversity Council, acknowledge that the land where we meet on and strive to protect is the territory of the Anishinaabe and the Haudenosaunee peoples, but now is home to many diverse First Nations, Métis, and Inuit people. That is also true for the many people participating in our summit who may be residing on unceded lands. I'd also like to recognize the critically important role of our Indigenous peoples in conserving biodiversity as teachers of traditional knowledge, for promoting and enlightening us on ethical space and two-eyed seeing, and as valued members of the Ontario Biodiversity Council. I'd now like to ask Dorothy Taylor, Elder, Water Walker, and Knowledge Keeper of Curve Lake First Nation, to share some important words with all of you. And first, by way of introduction, Dorothy Taylor is a Mississauga Ojibwe elder from Curve Lake First Nation. She is known for her work and traditional teachings about the sacredness of water. She shares traditional knowledge and ceremony within her community and various organizations throughout Ontario. She is a hand drummer and a singer. Elder Dorothy Taylor is the founder of the Sacred Water Circle, inspired by traditional Indigenous teachings and leading with hope and spiritual courage. The Sacred Water Circle sees a restored relationship between human communities and water. She has served as a volunteer on the Petroglyph Advisory Council of Curve Lake for 12 years. Currently, Dorothy is the co-chair of the local United Nations Sustainable Development Goal 6 on clean water and sanitation, sponsored by the Kawartha World Issue Center. She lives in Curve Lake with her husband, Mark, and 2 sons. Over to you, Dorothy.
Oh, Chimikwat, Steve. Nimkika panashikwa, Dishnaka, Swabagog Dodem, or Shkika Mong Donjaba. Gitchanandam Sanongam, Minka Kinamage au Sagil Sustainable Development should call that. My name is Dorothy Taylor, and I'm very, very happy to be here and be invited to be speaking regarding Indigenous environmental knowledge to such an esteemed group of people who have worked so hard and care so much for our natural world. I was asked to share a little bit about my understanding of Indigenous environmental knowledge. And first of all, what I want to say about that is, as Indigenous people, and I'm talking around the world, the globe, that we see, we feel, and we interact with the natural world more of a familial relationship. As you know, we refer to the globe of Mother Earth as Mother. We call her Mother. When we gaze upon the sun in the sky, we refer to the sun as Grandfather. And when we look upon the moonlight sky, the moon is Grandmother. And all the trees and animals and insects and the birds, they're our brothers and sisters. So you see how we have a familial relationship with the land, not necessarily a stewardship, because in our stories of creation, water was created first, the land was created next, and everything else was created that lives upon this world. But it was the human people, us, the four colors of man, that came to this land, the Mother Earth experience, I call it, because we're only here for a short time. We were here last. And so they welcomed us as the children of the earth. So when we refer to our interaction with the natural world as stewards, to me, the word steward is the definition as, as maybe something in which a person controls or organizes their interaction with the world. And, that's not our job. We have to have a different perspective on how we interact with the land and with the water. Because to Indigenous people, the water itself has a spirit, a living spirit. And the lakes, the oceans, the rivers, even the water that falls from the sky, it is the veins of Mother the Earth. And when we interact with the water, our elders say that we must show gratitude or speak gratitude towards the water. So many of you who work on the land and you're always near water, say on a daily basis in your language, be it English, Korean, Chinese, Italian, or Ojibwe, which is miigwech. Say miigwech to that water. It hears us and it has a memory. In terms of the land and the trees and the air and the fire, these are elements that must be treated with respect. So we have more of a spiritual relationship with the land. It's more than an element. It's more than it goes beyond being a resource. We actually have a spiritual, familial relationship with the land. So as the four colors of man, we must all remember our original directions as we left the Creator side. And just in brief reference to a certain part of our creation story, the white race was given the obligation to look after the air. the yellow race to look after the element of fire, the black race to look after the element of fire, of water, and the red race to look after the land. As Native people in the Ontario Island, which is the continent of North America, we believe that we still remember our obligation, and that's the obligation to the land. As you know, when you turn on the TV and you look on the news, it's always the Indigenous people who are leading many of those protests on oil and mining and forestry and such, because we believe that there are certain places on our land that have a spiritual power. It's a sacred place. Sacred meaning it has a connection to the higher power. So what I shared with you today in conclusion is that number one, we have a familiar relationship to the land. We believe that land, water, sky, and air, we have a spiritual relationship with it, with creation. And also, it's very important that on a daily basis, we speak gratitude towards those gifts the Creator gave us. And that we're not necessarily stewards of the land, but primarily, we must live in harmony. And we have to live in a balanced relationship with the land. So what I shared with you today, I just hope that what our elders from present and beyond and prior, who have taught me the little bit that I'm sharing with you today, that this will help you in the work as you go forward as professionals and in the work that you do. So I say miigwech for inviting me and to sharing a little bit that I know, and I wish you luck and have fun on this biodiversity and this group this conference that you're participating in webinar. Now miigwech, mi'il.
Wonderful. So before we get started, just a couple of housekeeping items. We will be posing questions to each of the speakers after their block of talks. So if you have questions, please type them in the questions box, not the chat feature, the questions box, please. And we will pose those to the speakers at the end of their presentations. Also, this webinar is being recorded and can be accessed on the Ontario Biodiversity Council website afterwards. So if you want to go back and rewatch it or share it with your wider network, that would be fantastic. So we'll move right along to our first session, which is overarching biodiversity concerns. So the two presentations this morning will be focused on kind of the larger issues surrounding biodiversity, ecological footprints, and climate change. So these are really going to set the scene for the threats to biodiversity, not only in Ontario, but globally. And our first presentation is Trends and Challenges Measured by Ontario's Ecological Footprint. And our speaker is Eric Miller. So Eric teaches graduate courses in ecological economics and sustainability informatics at York University's Faculty of Environmental and Urban Change, and directs York's Ecological Footprint Initiative, which delivers various projects, including the production of the National Ecological Footprint and Biocapacity Accounts. Eric is also a David Suzuki Fellow focusing on ecological economic literacy. His prior work as a consulting economist has informed governments, industry, think tanks, and NGOs. His earlier career in public service has led has him leading the team of economists in the Ministry of Natural Resources after he had worked for the Ministry of Environment and for Environment Canada. Eric is a member of the Ontario Biodiversity Council in his capacity with the Ontario Network on Ecosystem Services. So let's welcome Eric Miller, and he can take it away. And if you have questions, put them in the question box, and I'll pose them to him afterwards.
Great, thank you. It's my pleasure to present on work that we did on characterizing Ontario's ecological footprint and biocapacity and its trends from 2005 to 2015. I did this work with great co-authors, colleagues of mine, Jason Robinson, Marie-Louise McMaster, Elizabeth Holloway, and Anusha Kapoor. We're all very busy in new exciting roles that they lead in various organizations. I'll start off with the question of why the ecological footprint and biocapacity related to pressures on biodiversity. So I'll just reflect that around the world, a lot of the prominent analyses of pressures on biodiversity have used the ecological footprint and its comparison to the biocapacity of the planet as a key indicator of the pressures on biodiversity. You might be familiar with the economics of biodiversity, the Dasgupta report that came out just a few months ago this year, and hopefully you're familiar with the IPBES, the Intergovernmental Panel on Biodiversity and Ecosystem Services. They are among many others that have benefited from this information that we at York University produce on a global basis. And in this case, for this research project, we actually derive for Ontario. In terms of Ontario, Ontario has a State of Ontario's biodiversity report that will be released shortly. And we've already released 2 prior reports on the state of biodiversity in the past. One key focus on this report is pressures on biodiversity, and just to extract from that. The extract is, while discrete threats to biodiversity can be identified, the overall unsustainable use of biological resources driven by human population levels and consumption patterns represents a suite of cumulative stresses on biodiversity and is the overarching factor driving biodiversity loss. And with that, in Ontario, for the reporting on the State of Ontario's biodiversity, we use the indicator of Ontario's ecological footprint and its comparison to biocapacity as a key indicator of pressures on biodiversity. So with this then, with this focus on the overall unsustainable use of biological resources, that raises the question of how do we quantify the extent to which we are either sustainable or unsustainably using biological resources. So that leads to the sort of starting point conceptually with some minimum conditions for sustainability. And so when we think about all the stuff that we consume, all the things that we have built and set up on the lands, and all the things that are all the infrastructure and so on that transports us and all our goods and services and so on, we should definitely be mindful that all of that exists, of course, within a biological and biophysical context. And so when you think about the lands and waters beneath us and around us that sustain us, it's important to understand essentially the metabolic relationship that we have with the lands and waters around us and beneath us. And so when we think about that, we can think that we can quantify the importance of resource inputs as flows from from those lands and waters to us, and also about how all of our activities emit waste outputs into the lands and waters around us and beneath us. And so with this, when we think about this relationship that we have, this metabolic relationship of drawing things from nature, so to speak, and then emitting things into nature as well, we can think of some conditions for sustainability. So one is on the side of resource inputs. A minimum condition for sustainability is to use resource inputs at rates that can be regenerated. And when we think about waste outputs, the minimum condition there is to emit at rates that can be metabolized. And of course, being mindful that all the stuff that we establish on lands and in waters and so on, which should definitely be optimized considering trade-offs and pressures on biodiversity. And of course, trade-offs and pressures on biodiversity also are very important with regards to resource inputs and waste outputs, because all of that, of course, can be competing for space and materials and energy and so on from other species on this planet. So when we think about this, then this calls out the requirement to measure these flows in relation to the capacity to sustain these flows. And that's the intent of ecological footprint accounting. So ecological footprint accounting translates all of our stuff and the flows of things from the lands and waters as inputs, and also the flows of our waste outputs onto the lands and waters as an area that would be needed to sustain that metabolic relationship. More formally, the ecological footprint is the sum of various components that are additive, including fishing grounds, which represents the area of inland waters and marine waters that provides us with aquatic species that we consume as food. It also includes, of course, the built-up land component, which is the most visible and obvious to most of us. It also includes cropland, the area that is used to grow all the crops that we directly consume, plus also all the cropland that's used to grow food for animals that we consume as humans. It includes, of course, grazing land as well. Grazing land is the lands that are used by animals that we consume, that is not farmed by us, but is sort of harvested from, let's say, grasslands and so on. The ecological footprint also includes a component of forest products, representing things like timber, paper products, fuel wood, and so on. And the ecological footprint also includes a component of forest carbon uptake. So the ecological footprint accounts for our waste carbon emissions, and there's various ways to quantify the area needed to sustain that or to metabolize those. The way that we do it in the ecological footprint accounting is to quantify that as the amount of forest land that's needed to uptake those carbon emissions beyond the emissions that are sequestered by the world's oceans, which sequester about 30% of anthropogenic emissions on a yearly basis. So that's the area needed to sustain our metabolic relationships, the minimum area needed to sustain, of course. As I said before, there's necessary conditions for sustainability. It's not sufficient conditions, but even with this necessary condition, this is a minimum amount of area needed to sustain those metabolic relationships that we have. That can be compared to the area available to sustain those relations, in other words, biocapacity. And so biocapacity is also represented in these components as well, with forested land being available to either provide forest products or uptake carbon emissions. So that's the concept. And then going from the concept to the measurement, what we can do is we can make a comparison between these and all the components across the whole planet and over time by measuring these in units of global hectares, which is a hectare that's been adjusted relative to its local ecological productivity as compared to the global average. And so to do this, then what we do at York University is we harvest a lot of data from around the world, from great global databases and institutions and so on. And after processing about 45 million rows worth of data, we're able to quantify answers like this. In 2017, on a global basis, the ecological footprint was quite in excess of the biocapacity that would be able to sustain the ecological footprint in that year. That's what it looks like for 2017. We also generate results on a timeline basis as well. Here's a plot of the ecological footprint relative to biocapacity. So in each of those years where the value sums up above 1, that's where the ecological footprint is greater than biocapacity. From 1961 to 2017, you'll notice that since 1970, we've been in a period of global overshoot, where the ecological footprint is greater than biocapacity. And so that means in every year since 1970, this minimum condition for sustainability has not been met. And so then, not surprisingly, that's accelerated the crisis of losing biodiversity around the world. So if we look at this timeline, this is for the globe. This is a summation of all of humanity's metabolism relative to the lands and waters that sustain us. We also at York University generate these accounts on a national basis. And so this has been the trend for the Canadian ecological footprint relative to biocapacity in Canada over that time period. And a key question that was posed to us for our research project is, what's been the trend in Ontario from 2005 to 2015? And so to do that, we had to do quite a bit of additional research because Ontario's consumptions and emissions are not recorded in international databases. They're only recorded in data sources nationally or provincially. And so our task was to piece together all that information and sync that up with global databases and so on to derive what Ontario's share is of the global ecological footprint from 2005 to 2015, and how much biocapacity exists or has existed in Ontario during this time period. So I'll start off with how we derived the ecological footprint of consumption in Ontario. And I'll just note that the way that we do this accounting is we can specify the ecological footprint on the basis of all the activities or all the productive activities that take place in a jurisdiction within a year. And we can also quantify how much of that production was used for exports and how much was used for imports. And then with quantifying exports and imports and production, you can then put them together and derive the footprint of consumption, where the consumption is production minus what's exported plus what's imported. And so that's been the focus in our report for the measure of ecological footprint of consumption that took place in Ontario. So to derive this, we start off with the National Ecological Footprint Accounts of Canada, which, as I said before, we at York University produce those for the world. At this very moment, we're producing, we're enriching them and producing a future edition that will have even a longer time period than the one that I showed you there. We combine that with multi-regional economic accounts. Multi-regional economic accounts attempt to characterize the global supply chain of goods and services. And that's really important, especially for quantifying the ecological footprint of consumption in Ontario, because about a third of all the stuff that we consume in Ontario is actually produced in the rest of the world. And about a third of all the stuff that we produce in Ontario is actually exported to be consumed in the rest of the world. So it's really important to understand how our consumption and production relates to global supply chains so that we can quantify the ecological footprint of consumption in Ontario. And that's really important for Ontario because it's so, it has such a great proportion of consumption relates to trade flows in Ontario as compared to in other countries or other jurisdictions. And so with this, we were able to derive what's called a Canada Consumption Land Use Matrix, which is a very big table, about 200 rows. And each of those rows identifies a particular type of consumption. And then each of the columns quantifies the footprint components associated with that particular form of consumption. So for example, the consumption of footwear in Canada. How does the consumption of footwear relate to the ecological footprint in terms of everything from the fishing grounds footprint, the forest products footprint, and so on? And it's really important to appreciate that because of the way global supply chains work, even if you consume footwear, let's say, that footwear will still relate to all kinds of other sectors in the economy that then will relate to those other components of footprint. And so you might be surprised, how is there a fishing grounds footprint associated with my footwear? Well, there is, because that is used as part of in the supply chain of those involved in supplying things to those who make the footwear or ship them, et cetera, and sell them and so on. Now, from that, our task was to generate an Ontario consumption land use matrix to be even more specific about what the ecological footprint is for each of the components, for each of the types of consumption that took place in Ontario in those years of 2005, 2010, and 2015. And so to do that, we were able to harvest a lot of detailed data from Statistics Canada relating how Ontario, or what Ontario consumes, how much it spends on various consumption goods and so on, and how that compares to Canada, et cetera, so that we could calibrate or downscale the Canadian consumption land use matrix to the Ontario one. And we use the ecological footprint standards that allow us to derive comparisons between Ontario's consumption land use matrix and the consumption land use matrix, or even the tally of the total footprint anywhere on the planet at any point in time. So that way we can make comparisons. So after, so setting this up in terms of the method that we use, here are some results. So this is the ecological footprint of consumption in Ontario in millions of global hectares, the years 2005, 2010, and 2015. You'll see that in each of those years, there's been a reduction in Ontario's ecological footprint from its high in around 2005 of so over 130 million global hectares to the value in 2015, which is where we're just below 100 million global hectares. And this is broken out by the components that I introduced you to previously. So this is the total in millions of global hectares. It also helps to characterize that on a per person average share, because otherwise millions of global hectares are hard for the average person to sort of appreciate and understand. And so here's what it looks like in global hectares per capita or per person. So you take the total divided by the population in Ontario at that time, and then you get the results here that I'm showing you. So Ontario's ecological footprint in 2005 was 10.6 global hectares per person, and that's that reduced in 2010 and then in 2015. So that in 2015, Ontario's ecological footprint of consumption in that year was about 7 global hectares per person. These are the results at an aggregate level. We can also break those down into the components that I spoke about before. And so here's a breakdown by categories of consumption. So the first one at the top is gross fixed capital formation. So this is where we've got about 1.7 global hectares per person on average associated with gross fixed capital formation. Gross fixed capital formation refers to the building and renovating of physical things that occupy space and land and so on. So this includes everything from buildings, we've got utilities, we've got transportation corridors, we've got, yeah, and so on. So this tends to be, I mean, it's very footprint intensive activity. There tends to be a lot of concrete in that, which has a huge emissions profile associated with it, especially for greenhouse gases and carbon emissions. And so you can see here how the black colored bar, which is the requirement of how much forest we would need to uptake all the emissions from gross fixed capital formation that took place in 2015, is substantial. And the other components here, personal transportation, should be intuitive to all of us. You'll see that category has the forest carbon uptake being the highest relative to its total amount, and also the highest on an absolute basis as compared to these other categories too. And that's because obviously personal transportation is very carbon intensive. There's a lot of carbon emissions associated with personal transportation. And so there's a lot of forest lands that are needed to uptake those emissions if we were to sequester them on a sustainable basis, and so on. And these are, again, categories of consumption. We can go even further. For example, on the food category, we can break food down into its components as well. How the different components of the footprint relate to different aspects of the food that was consumed in Ontario in 2015 in global hectares per capita. So how much of the plant is needed to supply us on a renewed or sustained basis with bread and cereals, fish and seafood, nuts, meat, dairy, and all that sort of stuff. So this is the kind of data that's available that we derived. We derived this for each of the years, 2005, 2010, 2015. And so if you have an interest in some of these details or even in the big picture, I'd certainly encourage you to source our work and delve into it. So next I'll talk about deriving the biocapacity of lands and waters within Ontario. So of course that's to answer the question of how much lands and waters and what capacity does that have to sustain the footprint, which is the pressures that we put upon the lands and waters. And so to do this, we start off with Ontario's spatial inventories that categorize the lands and waters within the boundaries of Ontario. And so for that, we use the OLCC version 2. If you're familiar with land cover and so on, these will mean something to you. If not, for others, just the main point I want to make here is that we had to amalgamate or stitch together various types of land cover to derive the most current characterization of the lands and waters in Ontario. And so we took that, we melded it with Solris version 3 plus ecozone shapefiles. And by doing that and melding that with the National Biocapacity Council of Canada and its categorization of lands and waters and so on, we're able to derive Ontario biocapacity classes. So we could reclassify all the lands and waters within Ontario into specific categories of biocapacity that then sync up with all the analytics and empirics that we have that can generate or quantify those in global hectares. So we take the hectares of Ontario's biocapacity classes and then derive global hectares from them using Canadian yield factors, global intertemporal yield equivalence factors, and so on, and making use of a lot of data of the yields and harvests in Ontario from forests, cropland, etc. So with all this work, we were able to then derive an assessment of biocapacity. I'll just note that unlike economic statistics of how much is bought and sold in the marketplace on an annual basis, the statistics about the lands and waters in Ontario and indeed around the world are not as current. I think that does say something about how much attention or lack thereof we pay attention to the lands and waters around the world. We don't put as much effort as humans into quantifying and characterizing essentially like a census of the lands and waters in Ontario or even around the world. And so that did limit us so that we couldn't, it was a bit trickier to derive trends in biocapacity over that time period because the spatial inventories were not all in the same year. But I'll present some results for 2015 and some of the trends for some aspects of the lands and waters because that's still very informative. So this is what the biocapacity of lands and waters in Ontario were like more or less around 2015. I say around 2015 because not all the land use or land cover inventories were date stamped exactly to 2015. It's more or less. It could be anywhere from 2010 or even slightly before that up to 2015. But certainly for the southern part of Ontario, that was date stamped around 2015. And that's important because most of the transformations, the purposeful transformations by humans have been in southern Ontario, even though of course in the north has been transforming in a dramatic way as well, but that's been more from climatic changes, forest fires, etc. And so this is where we characterize the global hectares in Ontario from its inventory of all the hectares. And you can see the hectares tally translates into a lower total of global hectares. And that's because each hectare in Ontario provides biocapacity on average at a lesser rate than the global average, which is perhaps not too surprising considering Ontario's northern climate. There's sort of less primary production that takes place in the course of a year because of winters that slow down a lot of the metabolism, the biological metabolism that happens over that time period. These are the details, but we also aggregate them into these categories to sync up with the categories of ecological footprint. And so with that, you could see that the total global hectares is just below 100 million in Ontario in around 2015. One of the things that's there was a lot of work that we did in this report is that we attempted to characterize the biocapacity of wetlands in Ontario. Now that was pretty novel because in the global ecological footprint and biocapacity accounts for the whole planet, and including for Canada, there is no characterization of the biocapacity of wetlands. And that's because we don't have good temporal data and spatial data of wetlands over time. That is changing a bit. There are more recent spatial inventories of wetlands and indeed spatial inventories of sort of every bit of the planet, essentially. So you can derive some estimates very recently, but there hasn't been from 1961 to the present. So when we're producing the global footprint and biocapacity accounts, we don't include wetlands as a class of biocapacity. But because of their importance in Ontario, both just in terms of the number of hectares and also, of course, their importance from a biodiversity perspective and from a climate management perspective as well, a carbon management perspective, I should say, we decided that we should characterize their biocapacity. And so what we did was we sourced information of sort of Ontario-specific information about how much carbon sequestration there is by various types of bogs and fens and wetlands and so on in Ontario, especially in the northern part of Ontario where there's a lot of area of bogs and fens. And what we did was we, from that carbon sequestration rate, we were able to derive what the biocapacity is from a carbon uptake perspective. And so that way it makes it sort of, in terms of accounting, almost like equivalent to the equivalent of forest uptake lands, but we characterize them separately as wetland carbon uptake. So with that, that's what the tally looks like overall. I can share some remarks on trends up to 2015 for some types of these biocapacities, such as for forest and cropland and fishing grounds, because we do have data more specifically in each of the years, so we can get an assessment of trends. And so here's trends of yields from biocapacity in Ontario relative to the world average. When we were doing this work, we were of course comparing Ontario not just to Canada, but to the world as a whole, especially to derive global hectares, which involves making that conversion. And so with that, we derived yields in Ontario from inland waters, grazing land, cropland, and forest land, and we could compare those to the Canadian average and also the global average as well. And so this graph I thought you might find interesting. This is the yield from a hectare in Ontario divided by the yield from a hectare on average across the world. And so for each of the ones that's below 1, that's where the yield from Ontario is less than the global average. Everything where it's above 1 is where there's more yield per hectare in Ontario than there is from the globe on average. You can see that the trend, for example, in forest land here has been more or less constant over time, where Ontario is deriving in terms of timber, paper products, and so on from forest lands about the same amount per hectare over time. When it comes to grazing land, there's been a slight increase in how much food grazing animals we can consume off of grazing land per hectare. And most notably is, of course, the cropland component that really jumps out visually here. And that was interesting, quite surprising to all of us when we were doing it, but perhaps it's not surprising for many of you, especially in the agricultural sector, that are very mindful of just how productive and fertile the lands are in Ontario that provide us humans with crops. So the cropland in Ontario provides crops at a higher rate, or we've been deriving a higher yield from cropland in Ontario than the global average. Globally, there's a lot of cropland the world over that is in ecosystems where there isn't as much of primary production on an annual basis, et cetera, plus the techniques can vary, et cetera. So that's a little bit of characterizing the trends over time. So while Ontario's ecological footprint has been declining, the biocapacity of some of the components of land has been increasing a bit. So humans in Ontario have been deriving more from a hectare of cropland than in the past. So then I will then just comment a bit about changes in Southern Ontario from 2005 to 2015. So the other thing we looked at was changes in the land cover during that time period, just for the south of Ontario. And the reason why we could do this is because in the south of Ontario, we have detailed accounts of the lands and waters, where we don't have that for the north, so we couldn't characterize changes in the north, even though we really wanted to do that. So in Southern Ontario, here's a graph, a chart that shows the thousands of hectares gained or lost from 2005 to 2015 in Southern Ontario. What this is showing is, for example, in this case here for wetlands, we've got about 10,000 hectares of wetland that were lost during that time period in Southern Ontario. And then the coloration of this bar identifies what it was lost to. So most of the loss of wetlands was lost to this classification called undifferentiated, but there was also a component of wetlands that was lost to cropland, to extraction, or to built-up land. And on the positive side, for example, for built-up land, you can see that there was a gain in built-up land over this time period. And you can see for the gain in built-up land where the gain came from. So in here, this is the gain that came from wetlands. So of course, that's the same component here, just the symmetrical aspect of it on the graph. How much came from forest land, cropland, and from this undifferentiated category. You can see most of the play has been related to this undifferentiated classification of land. Of course, when we're accounting for changes in land, there's of course no more nor less land or water in total for Southern Ontario. There's still the same number of hectares, but by characterizing what's changed, we can understand trends, and then we can also quantify what that means from a global hectare perspective in terms of what the effect has been on biocapacity. So this undifferentiated land part is a big part of play, where a lot of like wetlands, forest land, and cropland gets lost to, or gets, I should say, transformed into undifferentiated land, and it's the undifferentiated land that is the main source for the sort of paving over of a lot of landscapes in Ontario. And so the undifferentiated land looks very much like this, that you probably see, especially around a lot of the cities in Southern Ontario. Now, the implication of all this is that from a biocapacity perspective, is that all those transformations taking place in Southern Ontario resulted in a loss of 70,000 global hectares of biocapacity in Ontario. So while Ontario's ecological footprint has been declining, and even though we've been deriving a higher yield from agricultural land, there's been the trend though of, with all of our land transformation, that on a net basis, we've lost biocapacity in Southern Ontario. So putting it all together here, just to wrap up, this is the picture from an aggregate perspective then of a declining trend in ecological footprint from 2005 to 2015, and its comparison to biocapacity in 2015. When we added in the quantification of wetland carbon uptake, that brings up the biocapacity amount to be almost equivalent to the ecological footprint in 2015. So to end off with some conclusions from our report, accounting for footprint and biocapacity helps to understand pressures on biodiversity. Ontario's ecological footprint decreased from 2005 to 2015, even as the population increased. Land development across Southern Ontario from 2005 to 2015 decreased biocapacity. Ontario's ecological footprint in 2015 was about equal to all of Ontario's biocapacity, which I should hope you'll react with just amazement. As many of you are well familiar, Ontario is a very big place. There's a lot of lands and waters in Ontario, a massive amount. And yet, all of that, the area equivalent in global hectares to all the lands and waters in Ontario's boundaries, is needed to sustain the consumption that's much more focused in mostly in Southern Ontario, although not exclusively. Ontarians' footprint is 11% below the Canadian average and 148% above the world average. As biocapacity becomes scarcer, we should put more effort into conserving it. And so with that, I would encourage everyone to take an interest in this and to think about opportunities to inform planning and policy and communications based on this work, especially with that breakout of footprint by different components. So you can relate that to impact metrics if you're doing analysis of the consequences from either more or less economic activity of a certain type, various development proposals, etc. And so on. So with that, I'll wrap it up at this point, and then I'll look forward to addressing any questions or comments that might have come in during this time period.
Great, thanks so much, Eric. We do have a couple questions for you. I'm not sure if you're the best person to answer this, but it came in during your talk, so maybe you have some comments on it. So can resources that are being used, like land for agriculture, for example, be returned to the forest area that they were before? And would that improve biodiversity, or is the area too damaged to return to its former state?
Yeah, really important question. I would say that the best experts to address that question would be those who are presenting in the summit on ecological restoration and ecological rehabilitation. So they're better positioned than I'd be to comment on that. The only thing I could say from the work that we did on the ecological footprint and biocapacity assessment is with that chart that I showed of the changes over time. In terms of that question, sorry, it was from the direction of change was from cropland to forested land, right? Was that was
Yes.
the question? Yeah. So from cropland to forest land, I'm just looking here back at the slide. I can share that again if needed, but don't necessarily need to. So the loss of cropland, which looked to be about 8,000 hectares or so during that time period. It was lost to undifferentiated extraction and built up land. There was no reduction, there's no transformation during that time period. There's no notable transformation during that time period of cropland being transformed to forest land. There are, as we all know, a lot of interest in afforestation, especially afforestation of cropland that, let's say, is not, doesn't yield a lot of crops for human consumption. There's also a lot of great work being done on transforming cropland to biodiversity lands through initiatives like ALICE and so on that many of you, I'm sure, are familiar with. And so those are all great initiatives that are meant to sort of do some of those transformations. I think at this point, looking at the data from 2005 to 2015, there wasn't a lot of that. So if we want to think about making that transformation, we'll have to think about that in the future and how to enable that. What kind of policy changes might be appropriate to support that. And at the same time, I would say to be mindful of the major challenge on top of everything else in front of us, which is that if we're thinking about the path to 2050 as the year when Canada and almost every country in the world has committed to net zero emissions, that does bring to mind the challenging question of if we go to net zero emissions, where we're going to do that as much as we can reduce aggregate emissions, electrify things that can be electrified, which we could do in Ontario at a lower carbon intensity than keeping fossil fuels, changing the way that we live, how we live, living more together in smaller areas so we don't have to heat and cool as much area per person on average, et cetera. As much as we can think about all that too, there's also a lot of interest in soaking up more carbon from the lands and waters in Ontario. That will be challenging because that land, that use of the land is competing against other uses, whether that's purely as a reserve for biodiversity, as a green space or a protected area, or whether that's lands that are used, let's say, to grow crops, not for us directly to consume, but as biofuels, for example. In Ontario, we keep sort of increasing the amount of ethanol in the gasoline. Well, that comes from lands and waters and so on. So it's really important to have this accounting to put it all into perspective. So anyways, I hope that's a helpful answer. Sorry, I can't directly answer the question, but hopefully that was also some helpful thoughts there for the questioner.
Yeah, definitely. Okay, so how does government use biocapacity classes to generate policy, or do they?
Well, I think policy tends to be a bit more focused on specific uses of lands for various things. But what I think would be really important is, from a policy perspective, when we're doing regional land use initiatives, planning, regional land use planning, regional sustainability assessments, and so on, that's where it's really important to understand the capacity of lands to yield various flows of ecosystem services and goods in relation to what our demand for them is. And so that to me is the scale at which it's really important to be mindful of this. So everything from natural heritage planning, land use planning, we've got forest planning that goes on. We've got questions about where to source aggregates for its consumption associated with buildings and so on. There are decisions being made all the time about, for example, the extent to which we can build buildings using timber versus concrete and so on. And that has a huge implications from a land use perspective. And so I think some accounting for biocapacity and ecological footprint together can be really helpful to answer these kind of questions that people are increasingly asking, but so far it's been really challenging for people in governments to answer them. I say that personally, revealing, of course, that I have previously worked sort of in that realm, leading the economists in the Ministry of Natural Resources and Forestry. And so I know there and the great team of economists that still exists in the ministry and that existed at that time too. We were very, very keen for more data that characterizes the capacity of lands and waters in Ontario and characterizing the changes over time too. because a lot of the hot policy files we were dealing with were all about competing uses of lands and waters. And especially from a political perspective, there's a lot of conflict involved with that too. And so that's where it's really important to have information like this. And I guess the only thing I could think of coming out of this work and this report, because all this data relates back to land use inventories and so on, is that perhaps it'd be really nice to put all this data back into a land use cover and then make that available, let's say through Land Information Ontario, so that either anyone in government or outside could use that as a spatial layer and overlay that with other things. Because when I'm thinking about trade-off analysis, especially from a regional perspective, I think it's really important to have spatial files you can overlay. And so you could overlay this on top of overlay of other uses of demands for or supplies of of stuff from the lands and waters in Ontario.
Right. That's great. Do you expect climate change to have a significant effect on Ontario's biocapacity?
Yes, I totally do. And my expectation of that, my understanding of that is built on my read of great research that people associated with the Ontario Biodiversity Council do and others. And so the changes involve, I guess there's various ways to categorize those changes. One of the ways of categorizing those changes, it's going to affect the quantity of, let's say, forests versus wetlands versus, et cetera. And it's also going to change the flows of ecosystem services and goods from those as well. Now, in terms of like sort of forecasting what that would look like from a biocapacity perspective, that'd be a really cool research project. But until we do it, I don't know what exactly that would look like. But if someone who's watching this has some good, let's say, like if anyone's projected if anyone has sort of spatial data projecting what the landscape will look like under various scenarios. And I think there's some great Ontario climate consortiums, I think, or something to that effect that have done some of that work. So I think it's maybe just a matter of another research project where we take that great work that they've done, intersect that with this, and then perhaps also include some forecasts of Ontario's increasing population that is being planned for, and what that means from from a sustainability perspective too. That'd be really important to do. It's really important to not just look back at what's happened in the past, but especially for the future, for a very challenging future, to look forward to do forecasts like that. So that'd be really cool to do. And yeah, I would just be really grateful if anyone out there would like to connect with me or with my research team I direct. That would be greatly appreciated. I did forget to end off on the one slide that has sort of a shot of photos of many of the people involved with all this, but I'll just also and the way to contact us. But if you can go to footprint.info.yorku.ca, and at footprint.info.yorku.ca, you can get access to email me or to check out some of our other work, or you can send an email to footprint, FOOTPRINT, footprint@yorku.ca, and that email will also go to me and some others at York too.
Fantastic. How is pollution factored into biocapacity?
So pollution will degrade and alter the biocapacity of lands and waters. And so as it degrades and alters them, it'll change, let's say, the yield that we can derive from them. And so that will show up as a change in the number of global hectares of biocapacity over time. Now, it's important, as I noted before in the presentation, it's important to have good snapshots at points in time of biocapacity. And in Ontario, there hasn't been sort of a regular systematic province-wide sort of snapshot of lands and waters, on this day, on this year versus that year, et cetera. I really hope there will be that in the future, because I'm sure that would be helpful to so many of us who are keeners about biodiversity and sustainability. And if there were those, it'd be much easier to understand the extent to which there's been changes over time. But I know, like from an Ontario perspective, a lot of Ontario's lands are covered in forests. And so from an aggregate kind of quantitative perspective, that makes a huge difference. And so with all the research and the quantification and the field work and so on that's being done, understanding the different dynamics of fire, of pests, and so on that's taking place in Ontario, I think that is really helpful to understand when we roll that up, what the differences are in everything from the composition from a species perspective of forests, and then if you overlay that with areas that are deemed to be harvestable commercially, that's going to affect what products and so on can be derived, of what quality and so on from those.
Fantastic. Oh, one more question came in right at the buzzer there. Do you ever look at valuing ecological goods and services as a component of biocapacity measurements? And if so, what good resources would you recommend for that?
Well, I am very interested in the question of the economic valuation of ecological services, ecosystem services. And as was noted in the introduction, I'm involved in the Ontario Network on Ecosystem Services. So there's a great use and relevance of doing that. But of course, it relates to the question being asked as to whether that is, whether that's the preferred way to get the answer to the question being answered, or a route like this. Obviously, like this is a physical quantification of the goods and services that flow from within Ontario's boundaries. This physical quantification has its advantages that can be very useful in some scenarios to answer some questions where, let's say, monetary valuation could be challenging or indeed problematic if it sends a wrong signal and so on. So that's where it depends on the issue and the question being asked, or the future of the scenario being considered, as to whether I would say that you would be preferring these sort of biophysical measures of demands on and supply of in physical units of global hectares, let's say, versus in units of, let's say, monetary equivalent. The monetary equivalent stuff is really helpful for understanding things like fees and fines and so on. But then when it comes to like regional land use planning from a sustainability perspective, issues of sustainability are best addressed from these sort of biophysical units like ecological footprint and biocapacity.
Fantastic. Thank you so much, Eric. It was a great talk, and I'm sure it gave a lot of people some things to think about. And hopefully someone does have some good projections on climate change that they can reach out to you guys and you can get a research project going on. That would be amazing.
Indeed. Thanks so much for the opportunity. Great. I look forward to connecting with many of you. Again, footprint@yorku.ca is how you can reach out to us. Thank you.
Great. Thanks, Eric. So I'm going to move us along to our climate change talk. This is the impacts of climate change on biodiversity in Ontario. And our presenter is Alison Clark, the Senior Policy and Program Advisor with the Ministry of Northern Development, Mines, Natural Resources and Forestry. It's a new mouthful, but we'll get there. So Alison has worked with the Ontario Ministry of Natural Resources and Forestry for more than 10 years in policy areas such as species at risk, climate change, and biodiversity. Most recently, her efforts have focused on land use, carbon, and nature-based solutions. Previous to working for the government, Alison spent time smelling flowers, chasing butterflies, and sticking her hands in soil as a plant ecologist and ecosystem restorationist. Some of her fondest memories are from the years she spent researching plants on mine sites in the Yukon, as well as working at the Alderville First Nations Black Oak Savanna. She lives in Peterborough with her husband and 2 children. So thank you so much, Allison, for presenting, and I'll let you take it away.
Thank you, Lauren. I am going to turn my camera off. Apologies, my internet is a bit touchy this morning, and no camera seems to be helpful. So thank you for the introduction, Lauren. Thank you for the invitation. I'm really excited to be a part of the summit and to be thinking about nature-based solutions with all of you. It's certainly very timely and is gaining momentum here in Ontario and certainly across the country and around the globe. So before I get into my presentation, I just wanted to provide a little bit about the mandate of natural resources and forestry to help situate the information that I'm going to share. So, you know, a part of our mandate is all about protecting biodiversity while promoting economic opportunities in the resource sector and outdoor recreational opportunities. We do this a number of ways. Natural resources and forestry is the lead for the Ontario government for biodiversity efforts. We are the one window for national and international biodiversity efforts. As a land-based ministry, we manage 90% of Crown land and the 30,000 plus species that make Ontario home through a number of different legislative and policy mechanisms. We do a lot of work, of course, through partnerships and collaboration. And sometimes a little less appreciated is that the ministry is a very information-rich ministry and does a lot of work to increase the knowledge base on natural resources and biodiversity and climate change through applied research and monitoring and identification of emerging issues as well to help support decision makers, not only from the provincial government, but also other levels of government and who are making land-based decisions. So I was asked to come here today and talk about how climate change is affecting Ontario's biodiversity and natural resources. And certainly global assessments rank climate change as one of the main threats to biodiversity. We've seen accelerated threats of this over the last 50 years. And also these complex interactions with some of the other drivers of biodiversity loss, like land use change, habitat degradation, and invasive species. On the flip side, or alternatively, we're also being told by global assessments and international scientific experts that in order to meet our targets under the Paris Agreement, for climate change, we will not be able to do that without biodiversity, without land, without the waters. So climate change is a major threat to biodiversity. Protecting biodiversity is a strong answer to helping us mitigate and adapt to climate change. So through the presentation, I'm going to offer some examples of work that's been done by Ontario researchers and the impacts that climate change pose. I want to preface a couple of things. I am a spokesperson for this work. None of this work is my own, and none of this work is simple. It is very complex, involving complex interactions at all levels, and capturing this complexity is very challenging. And our researchers do their best work to unpack it all, but certainly there's uncertainty still involved. And then after we talk about all those threats and impacts, we can take a collective breath and talk for a few moments about nature-based solutions. So first thing maybe to talk about here is how Ontario's climate is changing. How is it predicted to change in the future? So in 2019, a very important report was published by the federal government called Canada's Changing Climate, and the information on this slide and the next is from that report. And we've pulled out 3 sort of key pieces of information to share with you today. First is warming is happening. Canada is warming twice as fast as the rest of the world. And in fact, since 1948, Canada's annual mean temperature has increased 1.7 degrees Celsius. This warming is not happening spatially in a spatial uniform way. Northern regions are warming faster than the southern regions of our country. When we break this down into sort of Ontario numbers, we can see that both temperature and precipitation in Ontario have increased. So again, we've increased by 1.3 degrees Celsius since 1948, and more so and faster in the north. And it's in the same time frame, our precipitation has increased by nearly 10%. So it's not happening in a geographically uniform way. Warming and change is not happening in a temporally or in a seasonally uniform way either. We're seeing most of these changes occurring during the winter season in Ontario and across the country. Warming, minimum temperatures in the winter. So a lot of that increase in temperature that we're seeing over the last 50 to 70 years isn't just about those hot days that we're experiencing in summer, but it's hugely being influenced by the reduction in the cold days during the winter. We're also seeing increases in precipitation in the winter, and a lot of that precipitation is being, coming in the form of rain as opposed to. So I don't want to talk a lot about climate models. I'm not the person to really do that, but it is an important topic to kind of understand that, we're using these global climate models to make these projections. Scientists are continually improving these Earth systems and climate models, and they're being able to incorporate more and more sophisticated information on greenhouse gases and large natural processes, regional processes, and so many more components than before. When you're looking at models, you're usually looking at 3 different scenarios, sort of a low emission scenario, a medium emission scenario, and a high emission scenario. And so when you're looking at these results, it's a pretty big range of potential, futures that we could be dealing with, which makes a lot of that planning even more challenging. If you are interested in climate models, I do suggest reading that Canadian report from 2019. And if you have any questions from that, Canada actually does have a help desk you can call, and someone will actually answer and try to help you with your questions. So when we talk about biodiversity, we are often talking about 3 different levels and 3 different scales of biodiversity: ecosystem, species, and genetic. And when we think about the impacts of climate change on biodiversity, it's also important to be thinking about those 3 levels, as well as trying to think about and figure out the complexities and the interactions that happen, and how species will respond to changes in ecosystem, to changes in climate, and how the genes may follow through. So I've broken things down and talk about it sort of in that format here. So let's dive into ecosystem level impacts. We know that climate change is going to fundamentally alter northern ecosystems in Ontario. And one of the elements of this loss is going to be permafrost. Now, permafrost in northern Ontario is a globally significant region and landscape. It provides significant breeding bird habitat and habitat for other wildlife. The peatlands that cloak the area are storing thousands of years worth of carbon. The snow and the ice covered aspect of this landscape is also a significant cooling mechanism for the Earth, where the white surface reflects the heat and light that comes down from the sun back out into space, offering that cooling effect known as the albedo effect. A recent study in Ontario has shown that there is an increase in vegetation greening in Hudson Bay lowland, and this is a result of, is associated with permafrost melting, And a few of the observations that they've made from this are hydrological changes, and that these hydrological changes are influencing wildlife habitat in the far north. So we're seeing a reduction in water levels in lakes and wetlands, and this is reducing habitat availability for fish and wildlife. Also, an increased potential for landslides and erosion, sort of impacting those habitats and nests and dens of wildlife and birds. And then, of course, when you have this, like, you know, availability of water and this mobilization of water in this environment, you're also getting a mobilization of nutrients, heavy metals like mercury and sedimentation, all sort of impacting the aquatic food web, including the food that humans in the far north are consuming as well. And then as peatlands start to thaw, the release of methane is another sort of big concern, of course, that people are still, will be putting much more research into. So if we keep on the theme of ice, we can talk and move a little south in the province, we can talk about lake ice. And while lake ice cover is very variable from year to year, as you can see in that bar graph on the bottom right-hand corner, studies have shown that there has been rapid decline in ice cover on the Great Lakes since the 1970s, and with the greatest declines being on Lake Superior and then second on Lake Ontario. We're also seeing this similar trend of earlier ice off or less ice in the inland lakes in Ontario as well. And if you're like me and potentially haven't spent a lot of time in and around large lakes in the wintertime, it's hard to necessarily appreciate this ecological importance of lake ice. But certainly with the reduction of lake ice, we're seeing more impacts to our sandy dune ecosystems and other sort of coastal habitats from these storm surges and big waves that are now hitting the coastline of our lakes. Lake ice also serves as a protective and insulative layer for spawning habitat, particularly in shallow areas for fish species that spawn during the winter and fall. And there is impact being noted there as well. And then, of course, earlier ice off also means that lakes are exposed to warmer temperatures for a longer period of time in the year, and our lakes are able to absorb that heat for a longer period of time. And in fact, we are seeing warming of lakes in the province. Our researchers have been also noting from this the warming of lakes influencing drainage patterns, nutrient cycling, and the quality and quantity of available. And, you know, and particularly for fish. And as ectothermic or cold-blooded species, fish are particularly susceptible to temperature of the environment around them. And there have been documented declines in fish species and habitat availability due to temperature changes in some of our lakes, due to changes in how our lakes are stratifying in the spring and in the fall, and also due to changes in oxygen levels in the lakes, such as those that changes resulting from algal bloom. Some of the biggest declines have been noted in cold water species, which is probably not surprising for cold water species such as brook trout, Arctic char, and walleye. And some of the projections from our researchers have suggested that there could be up to a 50% decline in some of these species by 2050. And, you know, as humans are part of biodiversity and we're part of the landscape, you know, all of this does point to concern for, you know, our commercial and recreational fisheries, as well as rights-based fishing, as we continue to, you know, potentially see some of these declines happening. So, you know, thinking not of cold water species anymore, but warm water species such as smallmouth bass or largemouth bass have historically been sort of limited to southern Ontario. We are now documenting northward migration of species. And in fact, resource managers are already actively working to minimize this range of expansion to help protect those cold water species. And they're doing so, for example, by opening up the fish season for longer periods of time for these warm season species in these migrated areas. So that was the ecosystem level. Let's move on to sort of the species scale. And we've already talked about fish and migration and changes to warm water fish distributions. And we're already documenting this and seeing this in other species here in Ontario. So, you know, an interesting example is the nodding lady's tress orchid, which, you know, for an orchid has a pretty high dispersal capacity. And there's been, you know, documentation of species migrating northward beyond its historic range to the shores of Lake Superior. You know, another interesting example for me anyway is the Karner blue butterfly. The Karner blue butterfly lives in Oak Savanna and is dependent upon wild blue lupin to carry out its life processes. And it's been extirpated from Ontario since the early 1990s, last seen in Pinery Provincial Park, but it is still prevalent, or present rather, south of the border. And the U.S. Fish and Wildlife Services has done a lot of modeling work for this species with regards to climate change and have documented this southward retraction of their range and a northward migration back into Ontario. Now, because of the behavior of the Karner blue, it's not a big flyer. It's not like to fly across the Great Lakes unassisted. Fortunately, you know, some positive news is that there's a lot of land managers in Ontario, like Ontario Park, other conservation organizations, Alderville First Nation, High Park, you know, as examples, where they've been actively trying to restore Oak Savanna, actively, you know, building up the numbers of blue lupin. And so, you know, if this should happen, we have a lot of groups that are trying to be ready for that. When we, you know, just to kind of bring this to, you know, a bit of a higher level in terms of changes to distribution of and ranges, you know, when we think about, you know, the potential impacts of this resulting from climate change, it's often that we're lumping, you know, our predictions into two different groups. So, you know, generalists, those are species that have a general habitat requirement or tend to be good dispersers, and they have, you know, a solid ability to colonize new areas, to colonize novel habitats, and adapt to changing conditions. Of course, these are, you know, traits that invasive species have. And there's this, you know, general, you know, forecasting that generalist, you know, will be the species that expand and that are moving with the changing climate. You know, when it comes to specialist species, however, you know, these are species that tend to have poor dispersal capacity. They have very specialized requirements and limited adaptive capacity. You know, there tends to be this understanding that these species will be more vulnerable. And the Karner blue that we just talked about is a really good example of that. And also a number of our protected species in Ontario are kind of fall more within the specialist habitat. And so we can see that enhanced vulnerability already happening. A lot of work in Ontario has been done on white-tailed deer. It is a managed species, and a lot of work has been done over the last 20 years to think about and explore and understand potential changes to its distribution in relation to a changing climate. Now, historically, cold winter temperatures and deep snow have limited white-tailed deer distribution in the Great Lake area, but with warmer winter temperatures, with less snowfall, there are projections and predictions that white-tailed deer will migrate northwards. And whether, you know, it's because less snow means that they can more easily avoid predators like wolves, or less snow means that there's more winter food availability for them, you know, and a combination of things. And it's likely to be, you know, a bit of a positive thing for deer. There's, you know, could be some benefits that come and some for humans as well who hunt deer as a part of their lifestyle as well. There are also a number of concerns of what an influx of deer into a new environment and creating new dynamics with wildlife could present, and also concerns about, the potential to transfer wildlife diseases such as brainworm from deer to moose, for example. This is an area where there's definitely work will continue, and seeking to kind of answer and manage those likelihoods on the ground. So in addition to changes in species distribution, another topic of research that's common in climate change and biodiversity and natural resources is looking at how plants and animals may shift timing of key life events as our seasons change, as temperatures rise, as our precipitation levels are modified as well. And what we're seeing in Ontario is that greening up in the spring is happening earlier, and we're also seeing an increase in the duration of our growing season. And if you look at those two line graphs on the right-hand side, you can see that there's certainly a lot of noise and variation, happening through time, but a definite trend of earlier greening days and longer growing seasons. And one of the interesting things I find about, this information is how the three regions that are monitored are so closely following each other, even looking at mixed-wood plains in the south and Hudson Bay lowlands in the north. So that's kind of an interesting piece. And why this is important is because vegetation, signals spring. It's a key indicator for food availability, particularly for migratory birds. And when we think about, greening up, we think about these, interesting and wondrous and specific relationships that exist between plants and insects and birds, and how a changing climate, may get some of these, relationships out of sync. And so, what does this mean for biodiversity? How could this look? And lucky for all of us, we do have researchers who have been asking the very same questions. And looking at the potential for this out of syncness or this asynchrony in migratory birds. So researchers in our ministry, along with all of their partners and collaborators, have developed a really interesting public-facing app that you can take a look at various migratory bird species in North America. And they developed this app using over 7 million observations from eBird, and they developed these species-specific, spatially explicit estimates of migration and phenology for 56 different species in North America. And what they found in the study and in the development of this app is that changes in spring arrival of migratory birds are coarsely synchronized with fluctuations in vegetation green up. And the sensitivity to those fluctuations, those changes in green up, varies drastically between different species. And then when they dug down a little bit deeper into that sort of initial finding in their research, they also teased out notion that bird species that overwinter more closely to their breeding grounds tend to migrate northward at a slower pace and are therefore able to sort of keep pace with the greening up of vegetation along the way. A really good example of this with eastern phoebe, which is a widespread species. It overwinters sort of in the central latitude of the United States downwards to Mexico, so not very far from Ontario here. And it was able to substantially modify and pace its arrival date here in the province with changes in green up. So it was able to arrive when its food was available. Bobolink, on the other hand, which is a species at risk in Ontario and overwinters in the southern tips of South America, is only able to adjust its arrival time by a very small amount, putting it at more risk of arriving when its food is not available, and a reduction in breeding success. So we're at our last scale here, you know, genetic diversity. And, you know, genetics diversity is sometimes a little bit more challenging to understand with regards to, you know, the impacts of climate change. And there could be lots of people on this call and certainly out there in the world that put up their hand and give lots of examples. But, you know, generally speaking, you know, changes in genes happen over a slower period of time and are manifested in a different way than some of the actual where we're finding species and the timing of their movement, et cetera. But there's a lot of generalities that can be spoken of, and there's certainly a lot of examples, even here in Ontario, that we are seeing with regards to changes in genetics. So, but generally speaking, you know, climate change can lead to reduced gene flow within populations. You can have fragmented and isolated populations that could increase potential for inbreeding within species. And then also, as we go back to that concept of species migrating northward, that you know, range overlaps in similar species, and we have already seen, you know, that happening with golden-winged warbler, for example, in Ontario. It's a species of special concern on our species at risk in Ontario list, and the genetically dominant blue-winged warbler has been moving northward and competing with the golden-winged warbler and breeding with the golden-winged warbler and hybridizing with the golden-winged warbler as well. So that's an example there of how climate change is already impacting genetic diversity. So I just have one more slide on impacts on the theme one of this talk, but I really wanted to highlight this particular study that was done in Ontario Great Lakes Basin, and it looked at 280 species across 10 different taxonomic groups using the NatureServe Climate Change Vulnerability Index to assess the degree of vulnerability of various taxonomic groups. And, you know, it concluded, this report, that mollusks, fishes, amphibians, lichens are likely to be the most vulnerable to climate change, while birds, insects, and reptiles are likely to be less vulnerable to changes in climate. You know, interestingly, it also showed that 80% of species with global or national or provincial conservation rank or at risk of extinction are vulnerable to climate change, and that there's just huge variability between you know, these also taxonomic groups and what makes one vulnerable and one less vulnerable. So this is really a macro level assessment and exploration of taxa and their vulnerability. And one of the things that I find interesting about this and useful about this is its potential ability to support management decisions and helping us understand which taxonomic groups may require more immediate attention, more immediate action in order to ensure that we have that adaptive capacity and that resilience for them with a changing climate. And if you are interested in this report, there's also an associated free, user-friendly, and fully accessible, publicly accessible tool that goes with it, intended for practitioners. So now we can take that collective breath. I appreciate that, you know, even at a high level, it's a lot of information to process, and it's a lot of heavy information too. Now we can turn our attention and talk more about nature-based solutions. And I know I'm coming up on time, so we just have a couple slides about this. You know, nature-based solutions really is an excellent avenue to help us address the parallel crises of biodiversity loss and climate change. And I said it at the very beginning of the presentation, and I'll say it again, that biodiversity loss is, you know, increasing from the threat of climate change, And protecting biodiversity is one of our best answers to fighting climate change. And nature-based solutions is, you know, like I said, an excellent tool to help us see this forward. Written there in the italics on the slide is the definition of nature-based solutions from the IUCN, and I really like how it frames it, so I'm going to read it out loud. Nature-based solutions are intentional actions to protect, sustainably manage, and restore natural and modified ecosystems in ways that address societal changes effectively and adaptively to provide human well-being and biodiversity benefits. And, you know, the diagram that they have associated with this, I also really like, because it not just talks about these biodiversity benefits as an outcome, but, you know, we really need to think about biodiversity as the foundation of nature-based solutions. You know, without ecosystems, without species to, you know, act on to protect, sustainably manage, and restore, those positive societal, you know, benefits are just not possible. You know, and in addition to those biodiversity benefits, we're looking at climate change mitigation, both from an emissions reduction perspective and, you know, potential to store more carbon, climate change resilience and adaptation, increased food security, water and air quality, sustainable jobs, green jobs to support our economy and our lives, as well as spiritual and recreational and cultural opportunities, sort of all leading to this like overall human well-being improvements, and helping us, you know, work to that collective, you know, international vision that Steve talked about at the beginning of the day, of living in harmony with nature. So it's really, you know, it's a bit poetic, really, in how we can talk about nature-based solutions. And just really quickly, you know, we have these overarching actions to protect, to manage, and restore, but there's a lot of pathways in which we can get there, and a lot of pathways that we can get there in Ontario. And so just to, you know, sort of highlight these opportunities for forest and ecosystem restoration. And when we're talking about forest restoration here in Ontario, it's not necessarily just about afforestation of marginal or unproductive farmland or of industrial land, but also, you know, forest restoration of existing forest land to, you know, increase its resilience, increase its growth and its health and ability to adapt to change. You know, lots of opportunities to adapt through green infrastructure and ecosystem-based climate adaptation approaches, like creating wetlands near cities to reduce the risk of and costs of flooding, you know, rain gardens, pollinator gardens, rooftop gardens that provide food and habitat and also cool the immediate air. Ecosystem protection, I think, is something we all kind of, you know, understand. It's our traditional approaches to biodiversity in the past, but also sustainable agriculture. And our farmers are doing a lot of amazing work to bring in increased windbreaks and pollinator habitat and wildlife habitat and cover crops, you know, undertaking actions that are really inspired by nature and natural processes. And I think there's a lot of opportunities to do that more. But I just want to end on a note when we're thinking about these actions and we're thinking about nature-based solutions, and also recalling some of the information about changes to ecosystems and species ranges and all of these, you know, findings that we're having in these impacts to biodiversity of, you know, some of the traditional ways and historic ways that we've thought about restoration and all that may not be the way forward in all cases. And in that climate change lens of future looking, you know, ecosystem restoration may also be important in some circumstances to ensure that we have that landscape resilience and that adaptive capacity going forward. I think that's it for me. Thank you very much, and look forward to any questions if there are any.
Great, Allison, thank you so much. Yeah, we have a question, and just a reminder to anyone, if you do have a question for Allison, you can type it in the question box now, or I see that Allison's put her email address up there, so if you think of something in the future, you can reach out directly to her. But so the first question we have here is, in terms of nature-based solutions to mitigate climate change, does the MNRF collect data on carbon stored in the province's crown forests and how this is changing through time? Recent data shows that Canada's forests are no longer a carbon sink, but a source, and I'm wondering if we have data on this specific to Ontario?
The answer is yes. Yes, we do. We have, a number of different assessments of carbon in our forests here in Ontario, particularly the managed forests. So when you get down into southern Ontario, private land forests, it's a bit more challenging, although there are estimates for that as well. So the federal government does assessments for the National Inventory Report, including on Ontario's forests, and so they're, even though it's aggregated into a national level, there is that piece there. And researchers in our ministry also publish regular data on carbon in Ontario's managed forests, carbon in our parks, and you can find these available on the Ontario Forest Research Institute website, as well as in the State of Forest report. I believe a new one will be coming out at some point in the near future, but there was one published with data 5 years ago as well. In terms of, what these numbers are saying is that, our forests are a sink, and I would say a lot of the numbers nationally are also still projecting Canada's forests to be a sink, at least for the next 30 years. And granted, those numbers minus wildfire. So when you incorporate wildfire, it may look differently. So you can find those. So Canada's forests, or Ontario's forests rather, are a sink and are projected to continue to be a sink for the next 30 to 40 years. And we don't tend to look too much further than that, because the further out you look, of course, the less accurate and predictive capacity we have. So it's an important piece to take a look at that as well, for sure.
Great. So if we don't have any other questions, I want to thank you so much, Allison, for coming and presenting. That was a great presentation. And hopefully we can start implementing some of those nature-based solutions and do a little bit more work on that front in the province.
Agreed. I think so. And I think it's interestingly relates to some of the things that Eric was talking about in terms of biocapacity and just this trade-off as well of land use. Like, our need to grow food will not change. Potentially how we do it can change, but it's not an easy way forward. It's certainly worth all of us trying.
Exactly. I think that's kind of the name of the game when it comes to this whole webinar series, and this one specifically about reducing threats, is so long as we're trying, that's a good first step.
Well, thank you very much and have a great day.
Thanks, Allison. Great. So to kind of summarize the presentations this morning and the ideas that have really come out of it, I think it's important that we really consider Ontario's biocapacity when we're thinking about how we move forward and how we protect biodiversity in the province. The fact that our ecological footprint in Ontario is kind of right at that line for our biocapacity should be alarming to everyone on this call and probably everyone in the province, especially when we're thinking about some of these the ways that we can mitigate and adapt to climate change involves nature and nature-based solutions. We'll really need to capitalize on our biocapacity and expand it and try to reduce that ecological footprint moving forward. So I think we can break for lunch now. I really hope that everyone sticks around for our afternoon session. It will be a very exciting session. We've got talks on habitat loss, on Phragmites, wild pigs. We have a presentation from the Ontario Turtle Conservation Centre, and a really interesting talk about how hunting can actually be a biodiversity tool. So we'll reconvene at 12:30 and lead into our second session of talks. So I hope you all get a chance to grab some food and come back to enjoy our afternoon session. Thank you.
Hi, everybody. Just wanted to give a 5-minute warning. We're going to return back from our lunch break, so I see a few new attendees popping in. So for everybody else, go ahead and fill up your coffee, and we'll be back online in just about 5 or maybe 4 minutes from now. So we will see you soon. Okay, welcome back from lunch, everybody. Colin Casson here with the Invasive Species Center. I'm going to be moderating this afternoon's session. And just a few, I guess, introductory and context-setting words maybe before we jump into our first speaker. So First and most importantly, thank you for coming back. Thank you for bearing with our lunch break there, and very excited to see the participation today. Just as a bit of a reminder, today's webinar is going to be recorded. You're going to see and hear all of the audio and the slides being presented as well, and we'll be circulating that via email to anyone who registered, so to folks that are here today and all of our other registries as well. Just as another housekeeping note, as a reminder there's a question function over in the control panel. So if you're just joining us, you didn't catch the morning, you can see a little triangle beside the word question. And if you pull that down, that's a great way to get in touch with us and all of our speakers. After each kind of main theme break, we're going to pause for a few minutes of question that we can direct, just like we did this morning. And so with that out of the way, let's get going here. So today's afternoon session is really about on-the-ground concerns. It's a generic term we tried to link together some really interesting and important stories that are happening. So I'll do my best to kind of navigate through this. But as I said, my name is Colin Casson. I'm the manager of invasive species policy with the Invasive Species Center. And it'd be a mistake, I think, if I tried to frame this as we're trying to cover everything. I think one of the main themes here with the Biodiversity Council Summit, and certainly with ours today here, is we're trying to take what Biodiversity Council members see as kind of related stories of groups of people and networks that may not be as connected as we'd love to see. And so that's one of our kind of primary outcomes we're hoping to get to today, is introduce folks to maybe some new content for the first time, some new speakers, and some new opportunities for collaboration as well. So we've got 4 top-notch speakers for this afternoon that are presenting on 5 different presentations. And our first leadoff hitter here is Dr. Ann Bell from Ontario Nature. So give a bit of an introduction to Ann, and in the background, we're going to queue up Ann's slides and we'll be ready to go. So Dr. Ann Bell has been directing Ontario Nature's conservation and education program since 2007. She holds a PhD in environmental studies and has almost 20 years of experience working in the environmental sector. As a researcher, advocate, environmental educator, and a number of other hats as well. We're very delighted that Ann's going to join us today to discuss the role of Ontario's protected areas in conserving biodiversity within Ontario. And with that said, Ann, thanks for joining us, and we'll turn control over to you.
Thanks, Colin. Okay, so do I see that? Oh, I do. Excellent. Hi, everybody. Thanks so much for joining us today. I'm calling in from my home in Toronto on the ancestral lands of the Anishinaabe, Haudenosaunee, and Wendat peoples, and the current territory of the Mississaugas of the Credit under the Toronto Purchase, Treaty Number 13. Now, I'm just going to turn my camera off. I hope that's okay with everyone. I'll turn it back on again when we do our Q&A, but I think I can do a better job of advancing my slides if I don't need to be looking up. Okay. So for those of you who aren't familiar with Ontario Nature, we are a charitable conservation organization dedicated to protecting wild species and wild spaces through conservation, education, and public engagement. Oh dear. Colin, this is the wrong presentation.
Okay.
So I'm terribly sorry.
Oh, no problem, and we can sort this out. It's as we laugh behind the scenes, you get what you pay for, and this was a free webinar, so we're happy to kind of pull it on the fly here.
Oh dear.
Maybe, Ann, would it be okay if you don't mind perhaps sending the right deck over to Rebecca? I'll get her to go behind the scenes and help out.
Okay.
And do you mind if we maybe reshuffle the order a little bit just to keep things going on the fly? Okay.
I'm terribly sorry. Okay.
Oh, don't worry. Hey, this is the fun of it, and we're all used to this by now. No problem. So,
okay.
Eric Cleland and Keith Monroe, you've been notified. You're on deck. I hope you don't mind. We're going to shift to invasive species, which was actually our next block, anyways, and then we'll kind of go back with Ann on the habitat protection front. So, I'm trying to draw this out a little bit, Eric, to give you a bit of a pre-warning here. I hope you're listening in the background. I see you on there. So. Eric, if you can throw your mic on there just to make sure you're with us and are okay with this plan. I got a thumbs up by text. Okay, there we go. Thank you, Eric. Okay, let's mix it up a little. So I'm going to set the context here for a minute or two, Eric, just while we get your slides queued up and ready to go. And so our next session here is we're trying to tell the story which is near and dear to our hearts, Eric and myself, on invasive species. And it's such a broad issue that we face in Ontario around invasive species. We're talking about all taxa, we're talking about all groups of species, and it can be hard to relate them together. But really what Lauren Tonelli and myself wanted to do here with this session, thank you, perfect, is to try and paint the picture of kind of two ends of the spectrum here of establishment on invasive species. We have the species when they first pop up, and wild boar is going to be our second case study with Keith Monroe. But the lead off here is what does it look like when a species becomes fairly widely established? And what is the scale and order of magnitude of efforts that it would take for us to kind of turn that back a little bit and have some conservation success, and what that looks like for us in the context of today, which is biodiversity conservation and protection. So with that in mind, we've got two case studies here. We're going to go for about 15 minutes each in terms of content. And so Eric's going to lead off today with some frag talk and profiling a really important project that's been happening in Ontario related to Phragmites. So with that in mind, Eric, I'll give you a bit of an introduction, and then we'll flip the control of the slides over to you. So Eric Cleland today joins us today from the Nature Conservancy of Canada, where he's the Director of Invasive Species for Ontario region. And he's leading Canada's largest invasive species, invasive Phragmites control program, which is done in partnership with the province and the federal government as well, and lots of local partners as well. That's happening out of Long Point, which he's going to speak to today. Previous to his work with NCC, Eric spent 13 years with what was then the Ministry of Natural Resources and Forestry, and several roles before joining the NCC. So with that in mind, Eric, thanks for jumping in here, and welcome to the show, and hopefully you've got control over, and I'll turn it over to you now.
That's great. Thanks, Colin. I appreciate it, and happy to step in as needed here. Just waiting for the control buttons to show up at my end down here. Ah, there they are. Okay, thanks very much, Colin, and happy to present today. I appreciate the invitation to talk about our Phragmites work at the NCC. I am going to turn my camera off as I'm calling in from the wilds of southern Ontario in the Long Point region, and our internet connection is a bit spotty at best. So I'm just going to turn that off now, and we'll get right started. So I'm going to talk a bit today about reducing threats to biodiversity and species at risk. And really the area that I'm focusing on is the coastal wetland complexes in the Long Point region. So we look at this project, while it focuses on the removal of an invasive species, we do look at the project as truly a wetland restoration program, and hopefully we'll be able to demonstrate some of our results through some of these slides. So just a little bit of background for folks who aren't intimately familiar with Phragmites. That's one of our contractors there in the picture on the right, Eric Giles from Giles Restoration Services, working in a Phragmites stand deep in the wilds of the Long Point Peninsula and Lake Erie. As you can see in the picture, Phragmites is a very aggressive perennial grass. It spreads readily through a number of different methods, including seeds, rhizomes, and stolons. The stands are so dense they choke out other vegetation. Very little wildlife can live in these stands, and it's of particular concern at Long Point due to the high numbers of species at risk. Being an aggressive allelopathic nutrient competitor, Phragmites was identified as Canada's worst invasive plant back in 2005 by the federal government. And it's nice to see some movement in Phragmites management in Canada now, and especially in the last few years. There's really a groundswell of support for this work. And just to note, it is a European native, so there are no natural controls here in North America at this time. So why did we choose Long Point region for this special project? And the reason is Long Point has one of those natural coastal wetland complexes that still maintains its hydrological connection to the Great Lakes system. So it's not diked, it's not pumped, there's no management for the most part in most of the coastal wetlands found at Long Point. So it maintains those natural pulses, which are really important to a wide variety of wildlife, fish species, and plants as well. Long Point has been designated just about every possible designation that you can get in Canada. It's a biosphere reserve, it's an ANSI for both earth and life sciences. Of course, it's a provincially significant wetland, and it's been identified as a Ramsar site, as well as an important bird area due to the high numbers of migratory waterfowl and shorebirds that stop over at Long Point on their way to either their summer nesting grounds or their wintering habitat down south. As far as our records show, we see about 23 species at risk using these important coastal wetlands at Long Point, and they're very much imperiled by the increase of Phragmites over the last 15 or 20 years, particularly. And the other unique thing that I'll talk about a bit today is the support and interest on the part of the community and the landowners in the area provides an opportunity to have a landscape scale impact, which is really the way we need to manage Phragmites in Ontario. Just to give you a bit of an idea of the scale of Phragmites invasion at Long Point, you can see a good part of the shallow wetland habitats in the Long Point region and the Turkey Point complex on the north part of the map there are heavily inundated. And we're looking at back in 2015 when we undertook some mapping in partnership with Ducks Unlimited, we mapped over 1,300 hectares. And I have a circle around that number on the map for a reason, because what we've learned through the project over the past 5 or 6 years is that oftentimes the mapping grossly underestimates the amount of Phragmites that's actually found on the ground, at least with the technology available in 2015 when the mapping was undertaken. So a bit of background on the project itself. The project is unique in Canada because we have a special permission from the Pest Management Regulatory Agency of Health Canada to use a glyphosate-based herbicide called Roundup Custom, which has been used for over 30 years just across Lake Erie and our neighboring states in the USA for the control of Phragmites in aquatic habitats. Roundup has been available for dry land or terrestrial treatments for decades in Canada, but we haven't had an option for aquatic habitats, which of course is primarily where Phragmites grows. So accessing that herbicide has been a key part of our success at Long Point. The project began back in 2016 in partnership with the Ministry of Natural Resources and Forestry, which was their name at the time, and has continued annually through 2020. The big change in 2020 and 2021 is now a strong partnership with the Environment and Climate Change Canada's Canadian Wildlife Service joining the project and starting to manage some of their national wildlife areas, which are the last remaining strongholds for Phragmites in the Long Point region. We've had a ton of support for the project over the years from a variety of associations you can see there, but also directly from the community itself. The interesting thing about Phragmites is it impacts everyone, not just ecological values like those of us on the call are most concerned about, but also, you know, agricultural values, social and recreational values as well. So it really has a significant impact. And of course, if you're going to use an herbicide at the scale that we're using it for this project, we had to undertake a comprehensive monitoring program, which we have done for the last 5 years in partnership with Dr. Rebecca Rooney's lab at the University of Waterloo. So how do we do the work? Well, there's 3 main tools. We've applied the herbicide from a boat where we have access that allows a boat to get in there. We use a shallow John boat. We use amphibious track machines called Marsh Masters. You can see in the main image on the screen there. And we also use aerial application methods by helicopter. So just a bit about the aerial treatment. Of course, you need to give a lot of thought to delivering an herbicide control program in sensitive habitats. And there's a number of conservation measures that we put in place to make sure that we're doing the best good with the least amount of harm as absolutely possible. And so we calibrate the helicopter before it starts treatment to make sure that it is providing and applying the herbicide not only at the right swath width and density, but also the right droplet size. Droplet size is very important because it reduces the opportunity for drift off the target spray area. There are a number of label conditions we must follow. So the wind speed has to be very low, less than 16 kilometers an hour. The helicopter actually has to apply the herbicide at a very low height, a maximum of 3 meters above the top of the seed heads of the Phragmites. So very low, and these are risk reduction measures. The max speed they can be traveling is 60 kilometers an hour, and the droplet size must be at least ASAE coarse, which is a very large droplet size, about the size of your fingernail, which again is to limit the potential for drift. The nice thing about aerial application is it provides a consistent and uniform application, and it's very targeted and direct and avoids any footprint on the ground. So it really helps reduce our initial treatment potential for impact. And of course, choosing a good contractor is always critical. One with lots of experience doing this type of work is preferred. For the aerial treatment, we track everything using a GPS system on board from the aircraft. So here's an image of when we conducted aerial treatment in the Turkey Point Wetland Complex in 2017. The orange lines are tracking the flight path of the helicopter, and the greenish yellow areas are where the booms were actually turned on by the software in the helicopter and spraying Phragmites. And so what we do is we provide the aerial application company with a GIS shapefile of where the Phragmites polygons are, and the aircraft will then only focus on spraying those provided polygons. So it also provides the opportunity for increased safety for the pilot, who can then focus solely on operating the aircraft in those low and slow conditions without having to focus on turning the spray booms on and off as well. A little bit about the ground portion. So there are lots of areas where a helicopter is just not the right tool for the job, whether there's sensitive features or there's buffers in place or things like that. And all of those areas are done with ground-based equipment, quite often with a Marshmaster, as you see in the picture here. Again, we have all of those same label conditions that we work with regarding PPE and wind speed and timing and 12 hours before a rain, etc. We also have 2 operators constantly scanning the area for wildlife to minimize our potential for interaction with wildlife that might be using, say, the edges of some of the Phragmites patches. The way a Marshmaster operates in the marsh is a very slow, fast, slow, stop type approach as they apply the herbicide. So it really does help to minimize the opportunity for interactions with wildlife. We do a single pass through stands. So much like us, wildlife will use the path of least resistance. So if we make a trail, they may use it. So we try not to drive on that trail twice to, again, just try to reduce the risk of any potential accidental impact. And we avoid all of the preferred features for a lot of our species at risk, snakes and turtles, like rotting stumps, logs, debris piles, areas where thermal regulation may be occurring at the later summer treatment season when we're working. A little bit more about the groundwork. Everything is done GPS tracked on our ground crews as well. So we have tablets mounted in each of the machines with the Phragmites stands and any species at risk or other hotspots identified on the map, so our operators can avoid them. We have rules in place, like checking equipment prior to ignition to make sure that no snake has got in there to warm himself up on a warm engine compartment. It may seem silly, but we only apply the herbicide directly to plants. So it's not applied to the water body itself, but to the leaves of the plants directly. And of course, we use a micron filter around 100 microns to make sure that we're using clean water. Clean water mixed with the herbicide results in the highest possible efficacy, which then in turn results in a minimized need for follow-up treatments. And of course, we don't want to be part of the problem in spreading the seeds around, so we use our clean equipment protocols, and every machine is washed carefully before it leaves the site and goes to the next treatment site. We also use a John boat, as seen here. That's one of our contractors in a John boat to access sites where water is available in the right depth. That doesn't always mean it's easier. Sometimes you got to get out of the John boat and use the IntelliSpray hose reel system to do a lot of walking to treat single stems here and there or small patches. So it's definitely not an entirely mechanized program. There's lots of manual labor involved in this work. A bit about the monitoring. I mentioned this at the beginning. So Dr. Rebecca Rooney's lab from the University of Waterloo has been our partner since the beginning of the project, and we have a robust data set, and some really great published papers have come out of that lab in this project over the last number of years. Some of the things we're looking at as part of our monitoring program is really making sure that the surface water that local communities might be taking for their consumption is not impacted. So that's our #1 job in our monitoring program. Of course, we want to make sure that when we apply the herbicide, it's actually effective. So looking at the efficacy, we look at what happens to the herbicide after we actually apply it. So what does it do in the water column and in the sediments at the base of the water bodies where we're doing the treatment? We've also looked at impacts to aquatic organisms, which there is a lot of existing science for these products out there, and our results today confirm that there is no impacts to aquatic organisms through the application of this herbicide when done correctly and following label guidelines. Of course, we're working with Fisheries and Oceans Canada on the effects to fish and fish habitat and monitoring those. And again, our results have been incredibly positive over the last 5 years without negative impacts to fish and fish habitat. And as a matter of fact, we've restored a lot of fish habitat through this program. One of the pieces of work we're still working on now this year is sensitive vegetation community response. So what's the change after we remove the frag? What's coming back? Is it a healthy native, robust ecosystem, or is there other follow-up work that might be needed, or other invasives or secondary species moving in that we might be concerned about? And then lastly, at some stages through the project, we've been monitoring the impacts in benthic invertebrate communities. So looking at the food web from basically from the periphyton or the rock slime that starts the whole aquatic food web all the way up to the larger fish species and other wildlife that are using the site. So keeping a very close eye to make sure that we're not having an impact. And lastly, contributing our experiences to the Phragmites Adaptive Management Framework, which is led by the Great Lakes Commission in Michigan. I talk a lot about the herbicide because that's the exciting part of the project that isn't an option elsewhere in the country, but really it's just one part of an integrated pest management program. We also follow up the herbicide treatment in the winter months by rolling the Phragmites, sometimes cutting the Phragmites, and where possible and the conditions allow, we try to conduct a prescribed burn as well. And the Marsh Master is a key tool for preparing the site, as you see here, for a prescribed burn. One of the prescribed burns in action and one of the coastal wetlands in the Long Point region here. This was about 80 acres in size, this burn, in 2018. There are, of course, areas where you can't get in with a Marsh Master or you can't burn it and access it. So we do come back and get these smaller sensitive sites manually with still combi cutter tools. So really what that means is we hire unsuspecting, strong young people to come in the winter months and put in a lot of manual labor to prepare the site as best as possible for native plant recolonization the following season. And I guess the good news is it works. You can see here the pattern left by the aerial application in 2016 at the Long Point Crown Marsh, and this photo was taken in the summer of 2017, so a little over a year after the application period. The native vegetation is greening right up. It's really just an amazing ecological response to the resurgence of native species and the control of invasive frag. I mentioned earlier that we have learned that the work takes a lot longer and there's often a lot more frag out there as part of that. So to date, in 5 years, we have treated almost 1,300 hectares of frag. And if you recall from that first slide, when I showed a similar map, we thought we started with about 1,300 hectares. You can see now that we've controlled a lot of it, but there is still, according to our mapping, almost 650 hectares to go on the federal national wildlife areas. So just to raise the point that sometimes mapping greatly underestimates the impact of the species on the ground, particularly in remote areas where it's hard to access and verify. One last little blurb about a project that NCC has been partnered on for the last couple of years, and which really is a natural extension of the work we've done in the Long Point region. We're working as part of a group called the Green Shovels Collaborative, and this is together with the Federation of Anglers and Hunters, the Invasive Species Center, the Federation of Ontario Cottages Associations, and Ducks Unlimited Canada as well. And we've all come together to prepare a number of green projects that focus on mitigating the impacts of invasive species, but also stimulating the economy and creating some jobs as well. Over the past year, that group has been funded by the Ministry of Natural Resources and Forestry for a number of interesting initiatives. And one I wanted to mention here is the development of a strategic framework for coordinated management of Phragmites in Ontario. So this is really the first provincial response strategy for an invasive plant in Ontario. So we're very excited to be part of developing that document, and even more excited to begin implementing that. So that's something that hopefully will be on your radar in future months and years as this strategy rolls out and we work towards a more collaborative and coordinated response to managing Phragmites across Ontario. And lastly, just a big thank you, because this work really couldn't have been done without the support of the folks on the screen here and many others who I just simply couldn't fit them all on the slide, from our provincial and federal government partners, our fellow organizations with an interest in invasive species, and the local community and the Frag Action Alliance, as well as the landowners who allowed us on our property to do the work and really have provided a great contribution to conservation. So thank you very much for that. And with that, I'll turn it back to Colin.
Thank you, Eric. That was a great recap of a lot of work, and I love the note about your unsuspecting field crew, because that's who's doing the hard work there. So I appreciate it very much. So we're going to pause on questions for Eric. We're going to lump together both of our invasive species speakers into one shared question period, because there's some common themes here. I see a couple in the question box, but just as a bit of a reminder, especially for the newer attendees that joined us this afternoon, if you don't mind, start recording your questions into the question box, and we can kind of reflag them to the appropriate context as we go. So thanks for that, Eric. And Keith, we're going to go over to you now. So thanks for pinch hitting in here as well. So Dr. Keith Monroe is a wildlife biologist with the Ontario Federation of Anglers and Hunters, where he works on issues related to conservation of wildlife, as well as associated fields like disease and invasive species. Keith comes from a science and research background where he's lucky to have worked with a range of species, including white and black-tailed deer, small mammals, turtles, canids, and others. So Keith, thanks for jumping in here, and welcome. We'll flip the control of the slides over to you in a second.
Awesome. Thanks a lot, Colin. Happy to do it. And I think the way you set up these two talks is really good, as kind of extreme ends of the invasive species spectrum. I'll follow kind of convention and turn off my camera so people can see the full screen. And thanks a lot for having me. So today I'm going to talk about wild pigs. This is a species that I've spent a lot of time on lately, and it's a species that we currently don't have established populations in Ontario. So we're at the other end of the spectrum from Phragmites, but we can look at our neighbors to the south, and we can look at the prairie provinces and see what happens when you do let a species, especially like wild pigs, get established. So today I'm going to cover what wild pigs are, what are the concerns about them, and then what works and what doesn't work to address the problem. But I'm happy to say that we're starting at a position of not yet having, and hopefully not ever having, established wild pig populations in Ontario. Oh. All right, figuring out the controls here. There we go. So first of all, what is a wild pig? These animals are referred to by quite a few different names. In the States, they're commonly referred to as wild hogs or feral swine. Sometimes the term wild boar will be used, but in Canada, we've kind of settled on the term wild pig. And the sort of generally accepted definition, and the one that's used in Ontario, is that a wild pig is literally just any pig that is outside of a fence. So this could be a Eurasian wild boar, it could be an escaped domestic pig, it could be a pet pot-bellied pig that's either been allowed to wander or has escaped, or it could be a hybrid of any of those breeds. All pigs are the same species, they're all sus scrofa, and as a result, they can all interbreed. And especially when you look at US populations of wild pigs, they really tend to be these hybrid animals. Pigs are not native to North America or to the Americas in general. Any pig that's here was either brought here by someone or is the descendant of a pig that was brought here by someone. Pigs are incredibly fast reproducing, and they reproduce faster than any other mammal their size, which is the root of a lot of the problems and the reasons they're such a destructive invasive animal. Just to kind of give you a benchmark, white-tailed deer, which is probably one of our fastest reproducing mammals, will have between 1 and 3 offspring a year, with 3 being, in a good year in a good environment. In contrast, pigs can become sexually mature about as young as 6 months, and from there can have up to 2 litters a year, and very roughly those litters can be of 4 to 10 piglets. So just a whole nother level of magnitude in terms of reproduction compared to our native wildlife. Pigs are omnivorous. They can eat almost anything and eat quite a wide range of things, from plants to carrion to amphibians to nests to bird nests, and as a result, they're highly adaptable. Pigs need water to cool down. They don't sweat, so they don't do well in really arid environments. But other than that, there's very few sort of landscapes that wild pigs won't do well on. And we have them everywhere from the prairies of Saskatchewan all the way down to the Florida Everglades. So I'm just going to kind of step to a sort of a big continental scale when I start talking about where pigs come from. Because the very first pigs that were brought to North America were brought by Ponce de Leon and Hernando de Soto, who were early Spanish explorers in the early 1500s. And what my understanding is, this kind of one of the practices was upon making landfall, pigs would be deposited on land, knowing that they would do well, reproduce, and then there could be a reliable food source on future voyages. Pigs remain pretty local to California and the southeastern United States for hundreds of years. But then starting in the 1980s, we really saw a massive range expansion with then increased damages and management costs. And that expansion, I'm going to get into some of the drivers of it, but you can see from this map that from the yellow in 1982 to the red in 2012, they've expanded incredibly, and we've continued to see that expansion since. But it is important to note that, to kind of the best of our knowledge, wild pigs in Ontario aren't part of this expansion. I really encourage people to check out the government's annual report on invasive wild pig sightings. That's where these two maps come from. But what we're really seeing from the pattern of reported sightings is that the pigs in Ontario really seem to be recent escapes. We're not seeing large family groups, which is really good. So it appears that we're just dealing with pigs that have gotten loose, and that's kind of typified by these sightings of one or two pigs, but kind of scattered all over southern and eastern Ontario. So I'm going to dive into sort of the negative effects of pigs and why we really don't want them here. And fittingly, because this is a biodiversity seminar, the first one is just a very broad negative impact on biodiversity. So this graph is a study from Mississippi, where they looked at the vertebrate species richness. So they see the richness of species with backbones in forest patches with and without wild pigs. And what they found was that regardless of the size of the forest patch, when wild pigs were present, there was a 26% lower vertebrate species richness compared to forest patches without wild pigs. So very much across the board, just a very wide impact on biodiversity. Getting a bit more specific, we see specific impacts to both fish and wildlife. So wild pigs impact wildlife through competition. They eat many of the same things that our native wildlife eat. Predation, they would eat our native wildlife as well. And disease, wild pigs carry numerous diseases that could affect our native wildlife, but also livestock, as well as for some of the diseases, people as well. A really good example of a species that we think would be highly impacted in Ontario are wild turkey. Wild turkey are a conservation success story. They were extirpated from the province and then successfully reintroduced, and we have really healthy populations now. But research from the United States has shown that because they are a ground nesting bird, wild turkey are particularly susceptible to the effects of wild pigs. That same sort of relationship also holds true and has been documented for northern bobwhite. Northern bobwhite are a species at risk in Ontario, and the only known populations are on Walpole Island First Nation in southwestern Ontario. They're also a ground nesting bird, and they've also been shown to be negatively impacted by wild pigs. And while there aren't any specific studies, it's pretty logical to assume that this vulnerability of ground nesting birds would extend to other Ontario native species like ruffed and spruce grouse. Wild pigs are very much a sort of amphibious threat. As I said, they need water to cool down, and as such, they impact fish habitat and water quality by getting in water, eating aquatic plants, eating aquatic animals, sedimenting the water through kind of increasing turbidity, but then also spreading pathogens through their feces. And then, while it's not directly tied to biodiversity, it is important to recognize the massive agricultural damage wild pigs can cause. So in the United States, a very conservative estimate is that damage costs exceed $1.5 billion annually. And that could be through crop damage, it could be through competition or predation on livestock, or it could be through the spread of disease. And then one of the, I'll say, interesting things from a scientist's point of view, but scary things from a conservationist point of view, is that the more research that's done on wild pigs, the more we learn about their negative impacts. So when we talk about working to keep wild pigs out of Ontario, we're really talking about avoiding the negative impacts we know about, as well as the ones that haven't yet been identified. So when we talk about how we keep wild pigs out of Ontario, we're really lucky because we can draw on decades of management experience from the US. Later in this seminar, I'm going to give a talk about how great hunting is as a wildlife management tool, and it absolutely is. Unfortunately, wild pigs seem to be an outlier for this, and decades of experience have shown us that hunting is simply ineffective for both control or eradication of wild pigs. And the reason behind this is that in order to effectively remove pigs, you need to remove the whole family group known as the sounder at once. Typically, when hunting is used as a management tool, hunters will kill some, but the remainder of the pigs scatter, alter their behavior, and then that makes follow-up control methods much more difficult. And then, as I said, because they reproduce so quickly, animals killed are quickly replaced by reproduction. Estimates from the United States say that you need to kill a minimum of 70% of a wild pig population every year to keep it stable. So not to eradicate it, just to keep it from growing. And that's rarely, if ever, achieved through hunting. And then one of the unfortunate side effects of hunting, because it has been tried in the US as a management tool, mostly because it is so effective for other species that we look to manage for overabundance, like white-tailed deer that I'm going to talk about later. But what is instead happened is in many cases, hunting seasons have created incentives for people to spread pigs. When I talk about this, I want to be really clear that the vast majority of hunters are law-abiding, conservation-minded people. And when we talk about this impact of hunting on spreading pigs, we're really talking about very few unscrupulous individuals who could be hunters, but also landowners looking to charge hunters for coming on their property to hunt pigs, who unfortunately have had a really disproportionate effect. And the reason this has been possible is because a wild population of wild pigs is very easy to create. This is actually a truckload or trailer load of Texas wild pigs that were illegally imported into Colorado, which is a state that worked for 2 decades to get rid of their wild pigs. This was fortunately stopped by Colorado Parks and Wildlife, but very easily this trailer could have been, driven to good habitat, opened up, the pigs could have been let go, and a population could have been founded right there. The sort of classic example of how hunting can have a negative effect on the district, or a negative effect overall, but contribute to the spread of wild pigs is Tennessee. So from the 1950s to the 1980s, Tennessee had wild pigs in about 6 counties with some limited expansion, which you can see from the gray shaded counties in the top 2 maps. Then in 1999, a statewide open hunting season was instituted with the goal of getting rid of wild pigs where they were. This was ultimately ended in 2010 because it was ineffective, and a survey in 2011 revealed that nearly 70 counties now had breeding populations of wild pigs. with obviously associated increases in property and crop damage. And just to give a really clear caveat here or disclaimer here, there's absolutely no evidence that this is happening in Ontario. I'm kind of talking about this from sort of the broader North American context, but I definitely don't want anyone to kind of assume that hunters or landowners are purposely releasing pigs in Ontario. That doesn't seem to be the case, and we really seem to be just dealing with small localized farm escapes. So all that research and research experience and management experience has also really told us what does work for getting rid of wild pigs. And what we've learned is that wild pigs need to be handled by personnel with specialized training and equipment. And most commonly, the best option is trapping, which you can see an example here. And that's because trapping allows for this whole sounder removal, get all of the pigs off the landscape at once. The Ministry of Northern Development, Mines, Natural Resources and Forestry launched a pilot project in 2020 where they are actively investigating and removing or recapturing or removing pigs where appropriate, with a model that's really based on this best experience that we've learned from the United States. Then as a result, the OFH really encourages members of the public to report any sightings that they see so they can be followed up on by the professionals. And this is really because, classic invasive species, and I'll say that wild pigs are kind of the only invasive species that I work on, so I'm definitely not an expert like other folks on this call. But early detection is key because very few pigs can become very many pigs very quickly. And then once that wild pig population is established, it's incredibly difficult to control or eradicate, and it's very costly. So really, it's best dealt with before they become established. And we're lucky because we're at that point now. We don't have established pig populations. So by supporting early detection, we support early response by the government with the ultimate goal of dealing with the sparks now so we don't end up fighting a much bigger fire in the future. So that's it. I'll kick this back over to Colin, but I will say if anyone's interested in any of the advocacy work that the OFH has done on wild pigs, we've been probably the most vocal group in Ontario about this. You can check out our website, ofh.org/wildpigs.
Thank you, Keith. And it's a perfect note for a quick plug too on the to get everybody's trail cams maybe out of the closet or out of the cupboard and into the field as well. You've got a great field protocol there for monitoring wild pigs. So if I could just welcome Eric back as well there. Back in here, we've got a couple questions coming in, but just another quick plug if anybody's interested, if they could put their questions into the question function on the control panel. We've got a couple minutes here for questions still remaining. So I'll start off. There's a few frag ones in the queue. So Eric, I think I'm coming to you with these. There's a first question in here with respect to clean equipment protocol. I'd love to do a quick plug for the Ontario Invasive Plant Council's clean equipment protocol, which is a really good resource you can find on their website, I think ontarioinvasiveplants.ca, but I know you've got a bit of a modified one. Could you speak to that and maybe how you developed that and some thoughts on clean equipment?
Sure. I think that's actually one of the most understated things that we need to work on in the industries that we're working in natural resource management, whether it's in invasive species management specifically, or just those of us that are out tromping through these areas as part of our daily either work or play. The reality is we could be responsible for moving things around accidentally. So we actually do use the Ontario Invasive Plant Council's best management practices for clean equipment for industry. It's a great document, very thorough, has lots of great tips. The way we specifically do it with our equipment is because of the nature of applying herbicide from our track machines or marsh masters, we actually have water pumps on site in those machines because we have to refill our herbicide tanks numerous times throughout the day. So because we have gas-powered water pumps, we can hook up a pressure washer sprayer right directly on site wherever we are. We don't need to be hooked up to a water source specifically. We can do that remotely, and we power wash the machines off starting at the top all the way to the bottom in each cleat of every track and in and around all of the bogey wheels and everything as well to make sure that there's no seeds left behind before we transfer to the next site. And that also including the trailers as well, just to make sure that those don't have anything that have fallen off them or picked anything up as we back in and do our staging and offloading of equipment. So it adds a bit of time, but we pay for that time as well. So that is something that we pay our contractors to do by the hour, because we feel that that is just another part of doing the work. And that's something that I would recommend for organizations going forward, is plan to pay for that, require it in your contract, your fee-for-service contract with your provider, and encourage it as part of daily business.
So a bit of cost on the front end, right? But certainly some savings longer term. So
absolutely,
that's a great takeaway for everybody. So I'll do another quick plug on ontarioinvasiveplants.ca. They've got a one-page kind of summary fact sheet, which might be great to staple to a tender, perhaps, or a bit of a larger walkthrough how-to guide as well. Great question there. Okay, so I'll also circulate that link around. Maybe that'd be easier in the chat function for everyone. Another question here, what are the procedures? Oh, no, sorry, that was the same question. Somebody's looking for, so doing a quick search here and just looking for your perspective, I guess, on how probable or possible would eradication be? It's a big vision, I guess, right? So kind of pitched you as the widely established.
The E word. Yeah, the E word, that one comes up a lot. I think in some smaller populations and situations, eradication is definitely possible. If we hadn't received an aquatic herbicide, I would say it's 100% not possible to eradicate Phragmites from Ontario using traditional manual methods or non-chemical methods. But having the right tools to do the job and applying them responsibly and correctly and safely really does allow us to move the yardstick quickly, like we did in the Long Point, where we're over 1,300 hectares in 5 years treated. The reality is, I think our goal should not necessarily be eradication, but let's try to take Phragmites to a level where it's not having the ecosystem impacts to biodiversity and species at risk that it currently is. So if we can manage it to, say, 5 or 10% of its current extent in Ontario, that's a very reasonable goal. I think it's possible and something to work towards, and we'll achieve our ecological objectives for restoration of these sites as well. So I do think it's possible, and we do need to, all work together. It's really going to take a landscape scale approach, a lot of collaboration from, the volunteer groups right up to senior government officials and all the way through. It's going to take everyone working together, but I'm seeing a lot of promise on that front in the last couple of years, and yeah, it's really it's quite an exciting time. So I'd say we've got this. We can do it, but it might be to 95%, not 100.
Sounds great. Keith, question just came in here about what can we learn from other jurisdictions within Canada, I guess. Is there kind of a parallel story maybe to some other provinces or northern states? I know the southern US from your talks in the past might be a little bit different in terms of their level of establishment. What can we learn from our neighbors?
So really our two kind of Canadian provinces that we see dealing with wild pigs the most are Alberta and Saskatchewan. One thing I can say that we do quite well in Ontario is that we maintain dialogues between provinces. There's 2 working groups that are coordinated by the Canadian Wildlife Health Cooperative with funding through Environment and Climate Change Canada. And those include stakeholders, including sort of provincial and territorial agencies. So the biggest thing that I think it's important to drive home is we are talking to each other. Right now, only Alberta has an established strategy for dealing with wild pigs. Ontario just consulted on one that we're hoping obviously to see finalized soon. I think the biggest thing that we should learn from Alberta and Saskatchewan is that this can be a Canadian problem. I think a lot of views in the past have been that, well, we've only seen wild pigs in southern US states predominantly, therefore it must be a warmer climate problem. And I think for a long time, not everybody, but there definitely was the idea that it wouldn't happen in Ontario because it's too cold. But research out of Dr. Ryan Brooks' lab, the University of Saskatchewan, has really shown that wild pigs do great in cold winters because they can eat a lot of food. They can be calorie factories and just pump out body heat and create insulated nests. So I think we get a lot of the management strategies from the US, but I think we learn a lot about northern pig biology from Alberta and Saskatchewan.
Eric, can I translate that question over to you? But such a different species, such a different range, but just, thinking back to what we learned this morning, which was a presentation, I'm going to call them MNRF because the acronyms escape me right now, but we heard about climate change implications for a wide range of biodiversity. Just, curious about your thoughts, I guess, on FRAG's maybe distribution limit, maybe current range. Can we take a little bit of hope that it might be climate limited in the north, or what are your thoughts, I guess, on FRAG in Northern Ontario?
Well, it definitely grows differently in Southern Ontario than it does in Northern Ontario and in other parts of the country. So there definitely is some impacts to latitude. Is it a limiting factor? It's a slowing factor. It's not going to prevent Phragmites from spreading across the province. We've already got mapping that shows Phragmites right to the border, both on the Quebec and the Manitoba side. So it's definitely not limited. The good news, it grows much slower. The patches are much smaller. Hopefully it's easier to control. But I think the real message there is, and similar to what Keith said, is the early detection, rapid response is really critical. So right now we have a multi-million-dollar problem in Southern Ontario. We have an opportunity to prevent that in Northern Ontario. And that's really where we need to go over the next year or two, is to get on those early populations that are the size of your living room or even your kitchen table at the roadside and in those utility corridors. And we need to get those under control ASAP before we escape into the boreal wetlands and forests. Because once it gets through there, it's going to be hard to find and even harder to access and control.
Perfect. Two great contrasting examples. Appreciate your time, both of you. I'll do, we've got a bit of a mixed audience here in terms of where people's backgrounds and professional networks lie. So if I could go quickly back to each, I feel like a podcast host here, but to each one of you, where can we find out more, a little bit more about your work, about these projects in particular? Are there any meetings upcoming that people might be able to check out some presentations similar to dive a little bit deeper? Keith, could I go to you first and then we'll go to Eric?
Sure thing. So all our information about our work on wild pigs is at that website I did, www.ofah.org/wildpigs. And Colin, you mentioned something that I should have put in my talk. We've actually got a couple programs for helping to detect wild pigs. One is a fact sheet on how to set up your trail cameras to detect wild pigs and report them. And the other is actually a program where we loan out our own trail cameras for people to deploy them in areas of concern. So if anyone's interested in helping with that early detection and response, that's the place to go to find more information.
Perfect. Eric, where can we find out more?
Sure. So www.natureconservancy.ca, type in Phragmites in the search bar and you'll learn a lot about our specific work in Phragmites. And another area that I would encourage folks to reach out is longpointphragmites.ca. So that is a community-led website all about the intricacies of delivering the program at Long Point, including our public outreach and notification and all of our operational plans. So if you're a Long Point cottager, that's a great place to go to learn about the direct daily efforts. And then lastly, thinking about Phragmites in a much larger picture across Ontario, I mentioned that we're part of the Green Shovels Collaborative as well. So www.greenshovels.ca is a great place to go and see where frag management in Ontario is expanding to in the future.
Awesome. Okay, thank you both so much for your time, and thanks for jumping in a little bit out of schedule, but just appreciate the content. And I know it's a bit of a different audience from a traditional invasive species group, so thanks for bringing the message to some new folks as well.
Thanks for the opportunity.
For sure. Okay, so here we go on with the show. We'll go back to Dr. Ann Bell there as a quick primer. Ann's going to come to us again if we can queue up her deck. Ann's going to be presenting today on the role of protected spaces in conserving Ontario's biodiversity. What can we do from a land protection perspective, and how can that kind of relay into positive outcomes for biodiversity? So Ann, I can see you, and welcome to the show again. Here we go. I'm sorry, Ann, I had muted you before, so I'm going to go ahead and unmute you now, and you should be ready to go. Hi, Ann.
Okay, that's great. Hi, Colin. Thanks so much. And thanks, Eric and Keith. Thanks so much for jumping in and pinch hitting, as Colin put it. So embarrassing, and I'm sorry for the confusion, and I'm very, very grateful for the fact that you both stepped in and saved the day. And I really appreciated both of your presentations. I learned a lot. So thank you. All right, so on with the show. I'm going to turn off my camera, and away we go. So as I mentioned, I can just skip the first two slides, which I already showed, I think. Right. So I'm going to go straight into the premises of my presentation. There are two of them. The first is that I'd like to be clear from the outset that I consider the involvement and leadership of Indigenous peoples to be absolutely central to broader efforts to respond to biodiversity loss generally and habitat loss in particular. All of us need to do our utmost to ensure that conservation initiatives respect and uphold the inherent and constitutional responsibilities and rights of Indigenous peoples, as set out, for example, in the report of the Indigenous Circle of Experts pictured here. The second underlying premise of my presentation is that biodiversity loss and climate change go hand in hand. It probably goes without saying that habitat loss and degradation are the #1 threat to biodiversity in Ontario, Canada, and worldwide. For example, habitat loss threatens 80% of Ontario's species at risk. The impact of habitat loss on our most vulnerable plants and animals is not surprising, considering that in southern Ontario, where we have the highest percentage of species at risk, we've lost over 70% of our wetlands, over 98% of our grasslands, and over 80% of our forests. Southern Ontario is also the part of the province where we have the highest level of biodiversity, but the lowest percentage of protected areas, less than 1% in fact. But habitat loss is not just a problem in Southern Ontario. It's an issue across the province. Ontario Nature is quite concerned, for example, with the Ontario government's decision to exempt forestry from the requirements of both the Endangered Species Act and the Environmental Assessment Act. At the same time, the government's forest strategy aims to double the amount of wood taken out of our forests by 2030. A clear measure of Ontario's failure to do what is needed to respond to habitat loss is the fact that we didn't even move the needle on protected areas during the UN Decade on Biodiversity. And of course, the 2020 target of protecting 17% was in and of itself entirely inadequate for dealing with habitat loss and climate change. As we heard from Harvey Locke at the opening session of the Biodiversity Summit on May 26th, the science shows that what we really need is to protect at least 30% and up to 70% of our lands and waters. On the bright side, from that perspective, we should all feel pretty good about the fact that Canada has pledged to protect at least 30% by 2030. We need Ontario to commit to the same. But protecting habitat is not just about percentages and number of hectares. There are many factors that need to be considered in determining which habitats need protection, such as landscape connectivity, climate resilience, ecological representation, culturally significant species and places, and Indigenous responsibilities and interests. In his presentation, Harvey Locke distinguished between three global conditions: large wild areas, shared lands where about half the land has been converted by human activities, and urban areas and farmland where most of the land has been transformed by humans. Each of these conditions presents different opportunities for habitat protection. For example, the boreal forest in the far north would fall into the first category. Here, there is an opportunity and an imperative to protect vast unroaded landscapes that can support wide-ranging animals like woodland caribou. In this northern region, one of the most promising opportunities for protection is the candidate protected areas identified by forest managers whose operations are certified by the Forest Stewardship Council, known as FSC. There are over 1 million hectares of FSC candidate protected areas awaiting permanent protection in Ontario. They're pictured in bright green on this map. The table is set for success in that these are areas where industry and that have industry and community support for protection. Most of them have moderate to high conservation value, and to move towards permanent protection, FSC requires the free, prior, and informed consent of affected Indigenous communities. Further south, in the so-called shared lands, habitat conservation needs to focus on protecting and connecting core habitats. This typically requires knitting together a patchwork of private and unceded public land. For example, this map illustrates the Highlands Corridor, connecting the southern tip of Georgian Bay with several provincial parks and a conservation reserve depicted here in dark green. There are many local organizations, such as the Couchiching Conservancy, the Haliburton Highlands Land Trust, and the Jacks Lake Association, that are advocating for protection of parts of the corridor, illustrated here in red, brown, and purple. Well, kind of purple. Another important opportunity for protecting habitat in the shared lands involves expanding existing protected areas to buffer and connect important core habitats. For instance, the Ottawa Valley chapter of the Canadian Parks and Wilderness Society has been working on the Des Moines-Algonquin connection, which would expand on 4 existing protected areas and safeguard wildlife connections between Algonquin Park and the boreal forests of Western Quebec. And then there's Southern Ontario, where remaining wild spaces are so much less common and pressure for development is so intense. Strategies and opportunities for protecting near urban nature are examined in a new online report by the Southern Ontario Nature Coalition. There's a new kid on the block known as Other Effective Area-Based Conservation Measures, or OECMs. This new designation recognizes sites that meet the same criteria as protected areas, but where conservation is not the primary objective. The first OECM recognized in Ontario was the Queen's University Biological Station north of Kingston. Sites that don't quite meet the OECM standard can still be deemed candidate OECMs if the governing authorities intend to address gaps in protection. That's the case for Colonel Sam Smith Park in Toronto. It was assessed in 2018, but fell short of the OECM criteria due to concerns about foot traffic and off-leash rules. However, it's considered a candidate OECM because the Toronto and Region Conservation Authority and the City of Toronto plan to address gaps in protection. Looking again at the province as a whole, this map shows provincially significant wetlands on unceded Crown land. These are habitats that have already been assessed and identified for their ecological and social importance. Note the concentration of these evaluated wetlands in southern and eastern Ontario. Over 100,000 hectares of high-quality habitats that do not have to be purchased to be protected. This is a big conservation opportunity, and from a climate change perspective, of course, these wetlands are invaluable. We could grow this conservation opportunity by evaluating more wetlands. Most of wetland evaluations to date have been concentrated in the south, and even here, almost 50% of wetlands have not yet been evaluated. A straightforward and reasonable policy improvement to at least provide interim protection would be to require wetland evaluation prior to granting any development approvals. This is a map of areas of natural and scientific interest also on unceded Crown land. Like PSWs, these sites have also been assessed and identified for their significance. Again, the opportunity for protection is significant in southern and eastern Ontario, as you can see on this map. Now look what happens when you add candidate ANSIs to the picture. Almost 3 million hectares on unceded Crown land with some really large areas in the north. We looked at ANSIs and provincially significant wetlands more closely as part of the Southern Ontario Nature Coalition, with a focus on the Greater Golden Horseshoe, where only about 2.6% of the lands and waters are protected. Together, the ANSIs and provincially significant wetlands present a 73,000 hectare conservation opportunity on unceded Crown land in the Greater Golden Horseshoe. This spring, the Government of Ontario announced its intention to expand protected areas. In response, we worked with several partner organizations, including the David Suzuki Foundation, CPAW's Ottawa Valley, Wilderness Committee, and many others. We put together an online GIS story map of places that people want to see protected. We continue to add to the map. As you can see, there are dozens and dozens of candidate sites across the province. These include a few, but not all, of the Indigenous protected and conserved areas declared by First Nations in Ontario. Near the border of Manitoba on this map, for example, you can see the Indigenous Sovereignty and Protected Area declared by Grassy Narrows First Nation in 2018. For those who aren't familiar with the concept of Indigenous protected and conserved areas, also known as IPCAs, the Indigenous Circle of Experts describes them as lands and waters where Indigenous governments have the primary role in protecting and conserving ecosystems through Indigenous laws, governance, and knowledge systems. IPCAs are an evolving opportunity in Ontario and across Canada. Here in Ontario, we currently lack a provincial policy pathway for officially recognizing IPCAs, but several First Nations have taken the lead and are declaring IPCAs regardless. For example, Eagle Lake First Nation has declared the Faribault Peninsula on Eagle Lake near Dryden, Ontario, an IPCA. This site is ecologically and culturally significant, and its protection has strong local support. Last year, in the territory of the Williams Treaties First Nations, the Mississaugas of Scugog Island declared the Lower Duffins Creek provincially significant wetland to be an IPCA. This was to protect it from the proposed development of a warehousing facility on the wetland. One of the great benefits arising from conversations and initiatives focused on IPCAs is the way that they're challenging all of us to rethink what we mean by protection and conservation. There's no doubt that we must break from the past and from the colonial legacy of protected areas in Ontario and across Canada. While my presentation is focused on protected areas, I recognize, of course, that they alone are not sufficient to addressing the crisis of habitat loss. In an area like Southern Ontario, for example, habitat restoration will be vital to conserving biodiversity and mitigating and adapting to climate change. The beauty of restoration is that it can engage a broad spectrum of people: youth, farmers, city dwellers, Indigenous communities, new Canadians, experts, as well as amateurs. And it can satisfy that deep craving that so many of us have for hands-on involvement and on-the-ground tangible impacts. What else do we need when it comes to responding to habitat loss? Well, first, we need effective land use policy. Let's face it, most of our lands and waters lie outside protected areas. Ontario's provincial policy statement and its regional land use plans set out important rules to protect significant ecosystems and wildlife habitats and control harmful activities. Our work lies in improving and upholding those policies that protect habitats. Similarly, strengthening and upholding complementary legislation like the Endangered Species Act, the Environmental Assessment Act, and the Environmental Bill of Rights will be key to addressing habitat loss and degradation. I worry when governments step back from their oversight and enforcement role, especially with funding cuts to key ministries and agencies. We need government to understand and defend the public interest and ensure that our lands and waters are cared for and that their health and integrity are maintained for all life, now and in the future. And finally, we need informed and engaged citizens to keep an eye on things. All of us have a role to play in this, and if we step back, more habitat will be lost. The trajectory for biodiversity and climate is not good. It's frightening, in fact. Nothing less than a fundamental transformation of our social and economic systems is called for, and that means we have our work cut out for us. Thank you so much for listening. Miigwech.
Thank you, Anne, for the great presentation. It's so action-oriented, and you've given us so many deliverables and opportunities maybe to take away here for our calls to action list, which we're going to work on a little bit later. So thank you for doing that and framing it in such an effective way. Just a quick reminder there, if anybody's interested, please make use of the question box. We do have a couple to pitch to Anne, but just wanted to make a bit of a note for that there. We've got about 2 or 3 more minutes for questions, so don't let the opportunity slip here while we've got Anne on the line. And just really interested there, I guess, in terms of me kind of making out my list here of, asking you to help me do some of my homework here that we can pass on these call to actions onto the Biodiversity Council here. Some of the main ones I'm pulling out here is perhaps the opportunities that exist for IPCAs. It seems like such a great opportunity for a pathway and integrating that in. So great case studies and examples there you listed. Also really appreciate the fact about your stressing the idea of more wetlands to evaluate and how we can kind of integrate that into policy decisions. So just want to let you know that I took those away, and those are on my short list of things we need to include here. And one of the questions that was coming in here is to put you on the spot. Will Canada meet its 30% goal by 2030? Any thoughts maybe on our trajectory there, and perhaps any suggestions you could give us in terms of what we could be considering for actions out of that?
Well, that remains to be seen. I mean, we saw what happened with the 2020 goal. We missed it by a long shot. That being said, I think the progress that was made in the last few years was very substantial. And part of that, I mean, a really, really important part of that was setting the stage for Indigenous protected and conserved areas. And I honestly believe that that's the area of the biggest promise. And in trying to pursue those opportunities, that's where I think conservationists need to get, conservationists who aren't, Indigenous people, we need to get used to doing things in a very different way, and stepping back and trusting and standing up for those fundamental rights and responsibilities of Indigenous people. That's going to be our job in the years to come. I think one of the really nice concepts that was put forward and practiced and really highlighted in the federal work was the concept of ethical space. And that involves people coming together across cultures in ways that acknowledge and respect and give equal time for different knowledge systems and different governance systems. And understanding that question of governance, I think, is one that we're all going to need to work on.
An excellent point. Okay. Last call for questions. They can still continue to come in, and I think maybe at the end, if we do get some stragglers coming in, that's okay, and I can flip them. And just to give you the opportunity, again, I feel like the podcast host here again, but I see the ontarionature.org website up there, but is there one resource you could plug or one spot people can kind of go to find a little bit more info on some of the information you've discussed?
Well, I think we have a campaign page on our website, which is there. There's also on our front page is the story map, and I think that would be a really good place for people to visit. There are lots of, for all of those sites on that map, there are links to the groups that are working on those sites, descriptions, photos, the whole bit. There's a lot of information on that story map.
Perfect, thank you. I'm going to plug that in the chat function, so everybody watch out for that. And just to confirm, that's the tinyurl.com/yourprotectedplaces, correct?
Correct.
Perfect, okay. All right, I'll throw it in there. And thank you so much. Really appreciate the presentation today and how you laid it out so perfectly. Thank you again, and appreciate it.
Okay, thanks, Colin. Bye.
Okay, bye-bye. Okay, so as we switch presenters here, we're going to go between slide decks here, so hang tight with us for a second here. That was the end of our protected places one speaker session there, and we're going to shift pace to our last kind of themed idea, I suppose, of on-the-ground action. And so what we're calling that is novel threats and novel actions and opportunities here that we can be taking collectively. And it's a bit of a catch-all here, but there's a couple important stories we wanted to make sure would be told today in the idea of reducing threats to biodiversity within Ontario. And there's a great opportunity story here we wanted to make sure was highlighted. So we're going to shift gears over here to Dr. Sue Carstairs from the Ontario Turtle Conservation Centre to speak a little bit about some of the novel approaches the Turtle Centre has been taking here to kind of turn the story around on one of our groups of species that are particularly at risk. So we have Dr. Sue Carstairs here, who is the Executive and Medical Director of the Ontario Turtle Conservation Centre. It's a unique hub for native turtle conservation that's based here in Peterborough, Ontario. And Sue joined the OTCC in 2009. I'm going to embarrass Sue and put her on the spot here, but in 2020, I just wanted to make note that Sue's contributions to turtle conservation across Ontario were recognized with an appointment to the Order of Ontario. And we're very glad to hear her because I think this is a great story that I just want to make sure is told to our audience today who might not hear about it too often. So Sue, thank you so much for playing ball with us and moving your schedule around a little bit. I'm going to turn it over to you. I see your slides up there. Just want to make sure you've got control of the mouse and then it's over to you.
Okay, thanks so much, Colin. And yeah, thanks for inviting me and for giving me an opportunity to talk about the work we do at the Ontario Turtle Conservation Centre. And oh, there we go. And I'll also follow suit and turn my video camera off so I'm not distracted. But yeah, to talk about the work we do and our role that we play in maintaining biodiversity and reducing threats to Ontario's turtles. So obviously, talk today is lots of broad themed topics, and ours is a bit more zeroed in on turtles, but everything is connected. The web is always connected, of course, and turtle conservation is so vital to our wetlands biodiversity for sure, with turtles being often a huge biomass in those wetlands for them to be healthy. And I'm sure it's no surprise to anyone the number of species we have. So Ontario here, we have 8 species of turtles, and 7 of the 8 are designated as at risk in Ontario, and 8 of the 8 are at risk federally. And threats to Ontario's turtles, again, no surprise that habitat loss and fragmentation is the #1 threat to Ontario's turtles, but road mortality is second to that, so it's a pretty big threat as well. Fishing bycatch boating mortality is another lesser seen, but also a significant threat. Poaching is a very big threat too, and a lot of people don't know that there is a large illegal poaching ring based out of Toronto, of all places. So yeah. Predation, both natural predators and man-made predators, are also an issue. And then a newly emerging threat that we're seeing is disease, maybe introduced by released pet turtles. We don't know, but we're definitely seeing more of it. Now, I know that Ontario's biodiversity strategy is very multifaceted, and they have a very multi-pronged approach to the problem, and I think that's the only way really to approach a problem. So it's really interesting to hear all the different stories behind that. And we here at OTCC, we similarly have a multi-pronged approach, again, feeling that one thing leads to another, everything's interconnected, and also we can have a greater impact with this multifaceted way of approaching the problem. So we started out as a hospital due to the need of that immediate need. It started small, volunteer-based, and grew out of the increased need for sure, and the increased awareness. It grew and grew and grew out of the hospital, and now we admit about 1,000 to 1,500 cases a year in the hospital. Out of the hospital sprang the Head Starting program, because about half of the turtles that come in are females, and a lot of those are gravid. So we incubate 5,000 to 6,000 eggs a year. So that became quite labor-intensive and resource rich. So we decided we better put our money where our mouth is and make sure that work was actually going to be leading to increased recruitment into the adult population, and that it would be a viable conservation strategy in its own right. So that's how our field work came about, where we're tracking a group of post-release head-started juvenile blandings alongside a group of wild hatched blandings, comparing survival and behavior and so forth. Education, I think we find it's key. We have a standalone education program, but it's also something that we utilize throughout all our programs, any chance that we get. I think informing the public, inspiring the public, showing them stewardship actions they can do, just plain having them understand the issues can be so powerful. And then the data that we produce in all of these areas, we try and get that out to really work for conservation. So this is a bit more of an accurate description. Everything's interrelated. Everything relies on everything else. Whereas you could have each one as a standalone program, they work so much better together and they're so much more impactful. The hospital is so busy because of our extensive education program. The hospital creates the hatchling program. Data is utilized throughout all. So it's very much very integrated approach. And that allows us to have a greater impact, greater sphere of impact for sure, to not only reduce some of the negative effects of roads through the hospital, but increase recruitment through the Head Starting program, reduce the threats through engaging the public and educating them about all the different areas, preventing further losses by having our data be used in mitigation strategies, and then just really improving the knowledge by mining the data all that we can. And I think education, again, is just so key. We see so many amazing citizen science projects ongoing, and if we can plug people into that and get more and more people involved, that really is powerful, I believe. So the hospital started out of need. As you can see here, this is the road network in southern Ontario, and this is the home range of some of Ontario's turtles. So as you can see, they overlay almost perfectly. And for a species that spends a lot of time traveling on roads, they don't stand a chance with this road network. And road mortality, as I mentioned, is second only to habitat loss as the cause for the population decline. So anything we can do to buy time to fix the problem or to reverse some of those impacts is very important. And that's what we do at the hospital. We help to reverse some of those negative impacts and buy time to fix the problem. And that sounds very simplified, but we know we're not fixing the problem in itself, but it's one prong of the approaches that we take towards it. Utilizing the data, using it to educate the public, getting as many back out to wild as we can. These were the turtle releases across the province in 2020. So it does actually have a population impact. So the hospital's busy. It's really busy all year round, really, but especially May and still now and through till September. It's been a really busy year. We've had 1,100 admissions almost so far this year, and the eggs are hatching. So they're still coming in every day, and yeah, it's busy. And these are some of the typical trauma cases that we see. And the one takeaway point is that they're all potentially savable. So we give them all a chance because you never know which ones are going to do great and which ones aren't. There doesn't seem to be a prognostic indicator that's reliable. So we do try with them all, and these are some afters put back together. So about 90% of them are trauma cases, but not all. This big guy, he's a Muskoka snapping turtle, ancient old guy, and came up to the same beach every year. But the person who lived at this beach noticed a big mass in his mouth. So make a long story short, we had him for about 2 years as we worked through this. Eventually ended up having to go to Guelph, have a CT scan, have some major surgery because it kept growing back. And this year he was released back home. So that's one of the many different scenarios that we see. Another one was this guy. He's a Toronto Yacht Club, big old snapping turtle that was blind through a cataract, so had that cataract removed, and he was released back. So we do get some interesting cases. Fishing by catch, something we see a lot of. I had 2 fish hooks yesterday alone. So most of them are accidental hooks. It is, of course, illegal to fish for turtles in Ontario now. It doesn't mean it doesn't still occur in some places, I'm sure, but most of them are accidental catches, and a lot of them are brought in actually by the fishermen themselves. Predation, we see that a lot too, not only natural predators, but you know, dogs that find them in their yard. So these are, yeah, we see that a lot, and seems to be more this year with the hot summers. We seem to see a lot more. And we see occasional strange case like this guy we dubbed Iceman, who was walking around the ice in a warm winter thaw, and then it froze again. He got stuck in the ice, and he was there for 3 days. Apparently, someone thought it was a piece of wood, and then realized, oh, that's not a piece of wood. So we were able to revive him because he's a turtle, and they're amazing. And he got released. He was actually just local in the Kawarthas. So monitoring for disease, that's another really good byproduct of the hospital. Of course, anything that comes in with signs of disease are fully worked up so we can find out what is going on there. We have had quite a few herpes virus cases this year. We have a ranavirus case right now. So there seems to be more and more. But also what we do is we can survey the population of asymptomatic, so subclinical cases. We can monitor that and see what's sort of underlying out there in the population. And that's very useful, I think, for long-term monitoring generally of the healthy population. Things like this, ear abscesses is another way to monitor. We just did a study on these, and that's in submission right now. May or may not have relationship to the environment and contaminants. We don't have any proof of that, but it's strange that it's just in painted turtles. So surveying for disease, what can it tell us? Well, there's a lot of new and emerging diseases globally, and we need to know if these are going to be a threat to Ontario's turtles and probably other ectotherms as well. And monitoring for disease, interesting, it's not in any of the recovery strategy priority actions for any of the turtles, except the musk turtle. I'm not sure why specifically that. But you could argue that it's really important to do, because with species with so many threats, the added threat of disease, and particularly really infectious disease, could be devastating for sure. So we decided to do a ranavirus survey on cases that were subclinical, so they weren't showing any signs, but we surveyed them, and these were from turtles that succumbed to their injuries in the hospital. So we worked with researchers at Trent to do this, and combined it also with surveys of the ranavirus in the water bodies. And we found quite a high prevalence of that, which was actually surprising, because we don't, you know, I was hoping that the population was dealing with it quite well. It seems to be, we haven't seen that many cases of ranavirus this year that we know of, like clinically, but it is definitely out there. And when they do get it clinically, it's really bad. So, and it's transmissible through the water, and also transmissible to amphibians and fish. So this is quite of broad significance. And other ways we monitor the population, where all the turtles that are released are pit tagged or microchipped, and that way, if and when they come back, we can see where they moved from, what their condition is, and so forth. We've done some toxins studies. We did some PCB and mercury studies in snapping turtles some years back. And again, also looking at things like those ear abscesses and trying to determine if they're related to any environmental issues. Now, mining the hospital data generally, that's even significant. I think, like we wrote up, just something as simple as the sex ratio of the admitted turtles. We find year after year that as many males are injured on roads as females. And that came as a surprise to most people who thought that it was mainly females. So getting that out there might help to inform conservation strategies, such as head starting programs that might be preferentially incubating for females, for instance. This might sort of change that. And we also wanted to show that what we did in the hospital did have a population impact. So statistically shown that it can actually, in some situations, have that population impact that will help to slow that decline enough to help to buy time to fix the problem. You know, the implementation of eco-passages is fast becoming more the norm, and it's really heartening to know that there's so many projects going on across the province about this. So our hope would be to put the hospital out of business one day. Clearly that's not going to happen, but if at least we've been responsible for helping to buy a bit of time, then that feels really good. Now, the data that we used for that article just involved the adults that we released back into the environment. It didn't include any of the hatchlings. So we do release a large number of hatchlings back to the environment, either the same year that they are hatched or the following year, or in the case of our field studies, they have to be at least 2 years old to be big enough to hold the transmitters. So that likely would increase that impact even more. But we wanted to show that head starting was, in fact, likely a conservation strategy that was viable in itself. So that's why we started the fieldwork. We've been doing it for 10 seasons now. And we are following a group, as I mentioned, of head started blandings, juveniles, and a group that was actually hatched at the park that is comparably sized, but was hatched in the wild. We've recently also included ones that are of comparable size, wild hatch, but from outside the park, just to see movement patterns and how, if they change. We track them twice a week, all through the summer. We have a crew of 4 people out there. And then we've been analyzing that and just seeing the differences and how they're doing and what we can learn from it, and then transfer what we know to the other species that we head start. So very interesting, the findings. And we have found that to make a long story short, they're doing well. They're comparable in survival and behavior to the wild hatched species. And we find that after a relatively short period of acclimation, you don't know the difference there. They're basically wild. We do a very hard release, and that might have some impact on that. And then now we're trying to analyze the data on the ones that don't come from within the park, same genetic population, but from outside the park, to see if that impacts, if they also have an acclimation period or if they behave differently. So it's all very, I think, very useful information to get out there. There's a lot of head starting projects going on now across the globe, so hopefully we'll add to the information on those. And the fieldwork, actually, while we're out there, we have quite a lot of other collateral little projects on the go that have benefits. We found a previously unknown population of spotted turtles out there, and we always are making observations on species of plant and other wildlife that we see, people activity that we can inform the parks people about, so they can plan the park protection based on that. And we also do population surveys of other turtle species out there. We're always looking for more control juveniles for our control group. And in doing so, we catch everything else. So we found some interesting things there too. As one example is that in painted turtles, we see a male prevalence even in this pristine environment that isn't beside a main road. So interesting things that we accidentally find out. Now, education, as I mentioned, I do think this is so key. If you get the public behind you, it really, I think, is a powerful voice for conservation, and we see it more and more. They want to get involved. They want to know what they can do, even if it's just one little stewardship activity. Others want to get extensively involved. They want to actually be a part and help in the mitigation solutions. So I think that is so powerful. This is Wendy here, our education coordinator. So we zero in on the general public, of course, but also professionals, veterinary professionals, veterinary technicians, other rehabilitators, government organizations often come, but empowering everybody to have a voice and that they can make a difference, and that we all do our bit. We're going to really make a positive change. Public engagement is I think it stays with people, and then they talk about it with people. And our education program pre-COVID, it probably reached about 15,000 people individually, and then obviously a lot more if you include other touches like social media and phone calls. But it really, I think, is a powerful conservation tool that we try and utilize within all of our programs. And then other topics that aren't addressed by our hospital, or that people may know nothing about but may want to get involved in, such as the implementation of eco-passages, the impact of Phragmites. It's everywhere, and it can impact turtles and their habitat for sure. Poaching, a little known issue, but a huge threat to some of our turtle populations. Nest protection, what people can do on their own land. And then this is newly added was our turtle connections to the First Nations culture, which it ties in so well, and we are really looking forward to doing more work with First Nations to combine the two knowledge bases and produce a more enriched educational program. We have an indoor and an outdoor education center, and indoors we focus mainly on the turtles themselves, and outside more on the big picture. You know, what people can do, what are the threats, what stewardship activities they do to help, and really try and get them involved. So in a nutshell, that's about a summary of what we do, and a little synopsis there of our different programs and how they're interrelated. So again, thank you so much for giving me the opportunity to tell you a bit about it. And obviously, always a huge thank you to our major funders.
That's great, Sue. Thank you very much. We've got a couple questions coming in. I'll just do a quick plug. If anybody else has some questions for Sue, if you could put those into the question function. Sue, we're gonna, just to put these two together, we're gonna go over to Keith, if that's okay. Can I ask you to hang around for 20 minutes so Keith can contribute to the novel sections, and then we'll do a shared question period after that.
Yeah, of course, yeah, pleasure.
Thank you, that's great. Okay, so our next speaker on deck for the novel approaches section here is a familiar face to us. So Keith Monroe, Dr. Keith Monroe is coming back for another presentation here. So Keith is going to be speaking here to the opportunities for hunting as a biodiversity conservation tool. So Keith, welcome back, and I think we'll pass the controls over to you now.
Thanks a lot, Colin. I rarely get to give two talks, so this is great. But turn off my camera. And I thought a little bit about how this talk fits in with this section, the idea of novel actions, because when we talk about hunting, and specifically talking about hunting, recreational hunting as a regulated and monitored activity that's informed by science, that's really not novel when it comes to wildlife management. It's really fundamental to a lot of wildlife management in North America. But where I think the novelty really comes is very frequently when we talk to people outside of the hunting community, the idea that hunting has broader benefits to Ontario's ecosystems and specifically biodiversity. I think that's where the novelty comes in. And that's really what I'm going to try to tackle today, the link between hunting and biodiversity. And I'm going to do it using my favorite animal, white-tailed deer. And I'm quite biased with white-tailed deer because I actually did almost all of my graduate research on them. But they're also a really good example with some very clearly defined connections to biodiversity. And then the last caveat I wanted to give before I dived in was this talk is not meant to be a justification for hunting. That's an incredibly broad and complex discussion, and the reasons for people to hunt are as varied as the number of hunters there are. Instead, what I'm really trying to drive home is just that this is a broader benefit that the use of hunting provides to healthy ecosystems and biodiversity. Sorry, I did that last time as well, and there we go. So I don't talk about who I am when I give talks, but I think it's important in this situation because hunting is, it can be a contentious topic at some times. And if I just came out here and said, hi, I'm Keith Monroe, I'm the wildlife biologist for the Ontario Federation of Anglers and Hunters, and then dived into talking about all the benefits of hunting, it could be perceived as, a biased position. But I really want to drive home that I'm trying to come at this as objectively as possible. And I think my background kind of speaks to that. So I grew up in suburban Ottawa, avid, camper, hiker, canoeer, but I don't come from any family history or family background of hunting. And I didn't grow up hunting. I did my bachelor's at Guelph, my master's at Carleton, and then my PhD at Trent. And for all of those degrees, I worked very heavily on white-tailed deer. And specifically for my PhD, I looked at the behavioral responses of white-tailed deer to hunters. And through this, academic and research career, I really came to understand and appreciate hunting as an integral part of wildlife management. That then combined with my background in outdoors interests got me into hunting, but I always try to deal with hunting and the topic of hunting as a scientist first and then a hunter. And being a hunter definitely informs it, but I always have that science first view of things. Enough about me. Now onto the real star of today's talk. I told you I was biased. I really like white-tailed deer. So white-tailed deer are one of 4 native cervids in Ontario. The family Cervidae is the deer family. It also includes moose, elk, and caribou. Where white-tailed deer really differ from those other species is that white-tailed deer do very well in disturbed and fragmented landscapes. And the landscape modification that we've seen in North America post-European colonization has really benefited white-tailed deer. Deer are not creatures of the mature forest. They like edges and disturbances and fragmented landscapes. And as a result, we're now looking at historically high deer densities across much of North America. In Ontario itself, we have very approximately 400,000 deer. That's approximately because in the province, deer are managed based on population trends rather than exact counts. So if the population indicators show the population's going up, that informs management, and for some management actions, and if it shows it's going down, other management actions are put in place. That contrasts to a species, say moose, where our management is based on specific counts of the animals. But 400,000 is generally the value that is used. For this talk, what's really important is deer's feeding behavior. So they are browsers, which means that they feed on basically vegetation between the ground and about 2 meters high, both coniferous and deciduous growth, as opposed to a grazer, which is going to feed on grasses. And through this browsing activity, deer are what is known as a keystone species. And this means that they're a species that through their own actions, they can influence the broader ecosystem at multiple levels. And that's specifically what we're going to focus on today, the link between browsing and biodiversity. And deer can influence biodiversity through the level of browsing. And this is where it becomes really important and kind of a complex discussion, because it's important to always keep in mind that more wildlife, more deer does not always mean a healthier ecosystem. At intermediate levels of browsing, so what we would consider deer at sort of an ecologically sustainable level, they're actually shown to boost plant biodiversity. They create disturbance and prevent any one species from becoming dominant, and therefore increase the overall biodiversity. However, when you get deer to be overabundant, they can overbrowse, so browse in a non-ecologically sustainable level, and this in turn can lead to significant declines in biodiversity. So the sort of most direct link is their impacts on understory communities. So these are the plant communities that grow under the main canopy of a forest. And these studies are these effects are most commonly looked at through something called exclosure experiments. So this is an experiment where you go in, you fence off a portion of the habitat, keep deer out, and then you compare over time the vegetation growth within that exclosure and outside of that exclosure. So basically deer and no deer. The longest running of those experiments was conducted in Pennsylvania. They ran an exclosure experiment for 60 years, and they found that over this time frame, the mean understory plant species richness outside of the exclosure, so the areas that were available to deer, was 80% lower than the areas within it. And this has some pretty significant impacts on ecosystems in general, and you can end up with forests that look like this picture I have here. This was, I'm not going to say deer are the sole driver of this, but it kind of illustrates it. This was us in an area that's very heavily deer, has a very high deer density, and we were measuring understory density with a vegetation profile board. and you can see that there's pretty much nothing there. And then this is sometimes we see in areas like provincial parks and national parks where you don't have hunting or a intact predator community. You can lose your understory and come into a situation known as dead forests. So this is where you have a really mature tree canopy, but nothing growing up to replace it. So when a mature tree dies, there's no saplings or growth to replace them. And that in turn can have pretty significant impacts on all the species that then rely on those understory communities. The example I have here was a study also in Pennsylvania that looked at the impacts of deer browsing on bird communities. So De Calesta, he experimentally altered deer densities in various study plots and looked at the species richness and abundance of various bird communities. And he found that at high deer densities, you saw a decrease in both species richness and species abundance of intermediate canopy nesting birds, like this least flycatcher. And this sort of cascading effect across multiple trophic levels has a pretty extreme example, and that's black bears on Anacostia Island. Anacostia Island is a large island in the Gulf of St. Lawrence. It's actually quite a bit bigger than Prince Edward Island, but very lightly inhabited by people. Traditionally, Anacostia Island did not have white-tailed deer on it, but it did have a very healthy black bear population. White-tailed deer were introduced, about 220 deer were introduced in 1896, and by 1934, there were estimated to be over 50,000 deer. That had a really negative impact, leading to actually the extirpation of black bears, because the deer overbrowsed the understory, which included the deciduous bushes and shrubs that provided the berry crop that these bears relied on to put on their needed energy stores and fat stores for overwintering. They were so degraded, these understory communities, that even if you reintroduce black bears now, there's just not the sufficient food base to support them. So deer, through their browsing and when they get to be overabundant, can have pretty significant impacts on communities. But then we have to say, is this something that we accept? Are we okay with a population overstripping its resources? Because over time, a population will, if a population overstrips its resources, it will result in a population decline. However, with deer, those populations sort of fluctuations can be pretty extreme. When a deer population is removed from predation pressure, which is true over much of deer range, deer populations can grow rapidly in optimal habitat. With high deer densities comes overbrowsing, a depletion of food resources, as you can see for this picture here from the Ottawa Greenbelt. Basically, the deer have browsed off everything that they could reach and want to eat. And you also get an increased risk of disease transmission. Unfortunately, over the COVID-19 pandemic, we've all become very aware of the fact that large numbers of people in close contact supports disease transmission, and that's very true for wildlife too. We don't really have any major diseases of deer in the province, but there are several diseases that exist in neighboring jurisdictions that we are quite concerned about. And then in Ontario, severe winters, which our deer are subject to, can result in mass deer die-offs, especially if you have a deer population that's over its carrying capacity, that has outstretched its resources. So effective wildlife management helps mitigate population fluctuations by keeping deer at ecologically sustainable levels, which then reduces impacts on the broader ecosystem as well. And for deer over much of North America, hunting is the wildlife management tool that's used to do that. I won't go into all the sort of nuts and bolts of harvest management for white-tailed deer, but essentially the way it works is harvest is increased, when various indicators show that the deer population is trending above kind of where we want it to be sustainably. In Ontario, we have about 200,000 deer hunters who annually harvest about 58,000 deer. And this is used in a management point of view with the goal of sustainable management to maintain healthy populations for a broad range of benefits. And the harvest management strategies, i.e. hunting, are the methods used to achieve this. And this is right out of Ontario's population objective setting and harvest management guidelines for white-tailed deer. Now, that's not to say that hunting is the only wildlife management tool. There are a host of other wildlife management tools, and that could be an entirely separate talk. For deer alone, there's a wide range of tools for managing a population. Where hunting really differs from other management methods is that it is a revenue generating activity. So hunters are required to buy licenses to hunt deer, as well as all other species in the province. And 100% of those license sales go into something called the special purpose account, which is earmarked funding for fish and wildlife management. Other management methods for white-tailed deer, such as sharpshooting, trap and translocator fertility control, all have significant costs per deer. And this is important from a biodiversity perspective because the agencies that are tasked with managing wildlife and biodiversity don't have infinite budgets. So money that is spent on one thing is therefore not available to be spent on another. So hunting in this context offers a very effective and fiscally responsible wildlife management activity. And hunting also supports healthy ecosystems through things like data collection, as well as disease surveillance. So just in summary, white-tailed deer increase biodiversity at intermediate levels of browsing, but over-browsing has a negative impact. And this impact is across multiple trophic levels, everything from potentially plants to black bears. Hunter harvest is a tool that can be used to maintain deer populations at ecologically sustainable levels, and it does this while maintaining or while generating revenue for fish and wildlife management. So thanks very much. If you are, my plug again, if you are interested on the work that we do specific to white-tailed deer, you can find more information at ofh.org/deer. And I'll turn it back over to Colin.
That's great, Keith. Thank you very much for that. We'll invite Sue to jump back in here too, just for a bit of a shared block of questions. And just once again, last plug, last time, I promise. If we could make use of the question box just to keep things a little bit neat and tidy for questions and coming to our speakers. Perfect, thanks, Rebecca. So first question's coming in for Sue. Sue, could you maybe just elaborate a little bit on some of the, I guess, descriptions for some of the nature services provided by turtles to our wetlands?
Sure, yeah. So starting off, turtles, they're quite omnivorous. I mean, sort of their impact, their positive impact on wetlands, is that the question?
Yeah, exactly. Yeah. So just some of those services.
So the one thing we see is that they're really good cleanup crews. They'll eat anything. You see them all the time eating dead fish, cleaning that up. The young ones will eat bugs and mosquito larvae. Even the ones that we had start and release without any prior exposure to them, the first thing they'll do is grab a bug if they see it. So they're really good that way. They also eat vegetation, so they'll open up passages for smaller creatures to go through. So that's probably one of the biggest positive effects that they have is as cleanup crews in the wetland environments that they're in.
Perfect. Another question coming in about wildlife passages and maybe some opportunities and benefit beyond turtles. So just curious, I know you didn't talk a lot about it, Sue, there, but just your thoughts, I guess, on those being an opportunity to support, for wider implementation to support other wildlife.
Yeah, for sure. I mean, always, I think when eco passages are implemented, the goal is to benefit as many species as possible. And in that way, they've done a lot of work with the fencing itself. They did find that some of the earlier fencing, the snakes were getting trapped in it, getting caught as they tried to traverse it. So definitely, I mean, the species that are going to be positively affected by the eco passages that are put in specifically for turtles are obviously going to be quite small species. They're not, you know, they're under passages generally, so the bigger species can't fit through them. But some of the camera footage that they've had of some of the larger tunnels that they've put in, a lot of species have used them, from mammals, rodents, raccoons, turtles, everything. So it just depends. I mean, the most of them are focused on turtle protection, because they tend to be the ones that are most negatively impacted by roads because of their life history, but they do definitely help other species as well. And yeah, I was actually pleasantly surprised with how many projects are going on across the province in this, and successfully too, with pre and post studies. So most recent one in Brampton, the Heart Lake one, they've done some really good work there.
Very nice. Okay. Okay, thanks, Sue. Question for Keith that just came in. Keith, people are interested, I guess, in, you know, the white-tailed deer being the perfect example that you highlighted here. Just curious, I guess, you know, how widespread would the other examples be in terms of wildlife management opportunities?
Yeah, and I think that's where it comes back to the, you know, is this an example or is it a justification? Because there's definitely species that we hunt and harvest and manage where we don't have that clear sort of, you know, need to maintain an overabundant population. But sort of good examples that are quite similar, probably Canada geese and snow geese. They're two species that can have pretty big population level impacts. I'll be honest, my best examples are always deer, so I lead with that. But I also want to be kind of upfront that this is me picking deer as an example to illustrate it. I will say that in terms of, you know, scale and impact, deer are also probably one of the most applicable, just because if you look at, you know, North American wildlife, both in terms of abundance as well as occupation of their historical range and actually beyond, deer are one of the, if not the most widespread of these species. So when we're talking about, you know, effective wildlife management for boosting biodiversity, we generally are talking about white-tailed deer. But snow geese and Canada geese are probably the next two that come to mind.
Perfect. Just not sure what the question is. It's coming from me, this one. But just, you both have a bit of background and interest here in wildlife diseases and kind of opportunities for spread through your own kind of models, right? I guess, you know, first for Sue and then maybe Keith, whatever the translated version for your system would be. But just kind of curious, I guess, you know, ranavirus seems like an opportunity for us to address one disease that has many opportunities to spread through turtles as their vector into other wetlands and have implications for other species. So Sue, I guess just your thoughts from your experience on the threat it poses maybe to other species, and how significant of an opportunity or threat is this?
Yeah, that's a really good question. That's one that we're trying to answer as well. That's what we pose in our last article, was that although we're not seeing mass die-offs in our turtle species as they are seeing in some places of the world, it definitely has a more negative effect on amphibians, and we know that they are not as tolerant to infection. So what we wanted to find out was, we know in theory that they can transfer through water to other ectotherms. So we want to know, are they acting as a reservoir for other species? Are they causing a problem or not? We don't know. And the one thing I wanted to find out was the turtles themselves, can they clear the infection? So if we had a positive in a live one, could we then follow it and see that the viral load was decreased over time and eliminated? So that would have a big impact on overall effect of other species and the transmissibility, I think. But I think the bottom line is we don't know, and that's why I think these surveys are so important to do. We do about 100 swabs randomly on live turtles every year, and then we did that big study on deceased turtles in the organ tissue. and of course anything that has clinical signs. So we're always trying to learn a little bit more about the ecology of it to see how it fits into the big picture.
And Keith, I know chronic wasting disease is near and dear to your heart. Just any thoughts maybe on the implications of that and the level of threat, I guess, it poses to our biodiversity?
Yeah, so for people who aren't familiar, chronic wasting disease is a disease that's known as a prion disease. The one of those diseases that people are most familiar with is probably mad cow disease. They're similar diseases, with the difference being that chronic wasting disease affects wildlife, specifically members of the deer family. Right now, we don't have chronic wasting disease in Ontario, but it's in several jurisdictions neighboring us. Michigan has it, as well as a Quebec red deer farm had it just 15 kilometers from the Ontario border in 2018. So it's something we're quite concerned about getting into the province. If we did get it without early response, kind of going back to my my boar talk or my pig talk, it's really hard to get rid of. Only one jurisdiction has knowingly done that, and that's New York State. They responded very quickly and got rid of it. The tie-in for hunters is the surveillance that supports early response for chronic wasting disease is 100% based on hunter submitted samples. So when hunters harvest deer, if they're in a disease surveillance area, which rotate around the province each month or each year, they submit samples from the brain to be tested. And without that hunter submission, we won't know if we get it, and we won't be able to respond. And the sort of broader concern is that if it gets into deer, it could potentially get into other species. There's a lot of concern in Saskatchewan right now about it getting into the boreal caribou populations, which would then obviously have massive biodiversity impacts. Just as a kind of broader disease topic, Ontario is pretty lucky when it comes to wildlife diseases. Especially for deer, we don't have a lot of them that some of our neighboring jurisdictions have. But one thing that we encourage hunters and anglers to do is report anything that they see. I think Dr. Carcer has made a great point where she said that a lot of the turtles that come in with fish hooks are brought in by the anglers themselves. And I think hunters and anglers are people that spend a lot of time outside in nature and care about nature, and also have this familiarity to say, that's normal, that's not normal. And we really encourage anyone, but we talk to especially anglers and hunters, to say, if you see something that's not normal, make sure you report it. You can report it to the Canadian Wildlife Health Cooperative. And that's going to be really key to early detection of diseases, which we're probably going to unfortunately see more of in the future with the changing climate.
It's a great point, and I'll put it into a more succinct call to action, because there's not related to you, but just we've heard that theme through a few speakers today about like maximizing the people power who are on the landscape, whether it was through Anne's talk about restoration and that being kind of a capacity builder or interest builder in our some of our audiences. So there's a nice unique thread there that's kind of going in between all of these presentations. So it's an excellent one. It's down on paper. Thank you very much for that, Keith. Okay. In closing here, we're right up on the clock here, so could I give you a last couple seconds to pitch maybe one more link, one more resource, Keith, if anything comes to mind, and then we'll go over to Dr. Carstairs as we wrap.
So I would actually I'm going to carry on the disease part, because I think it's super important. You've put some other posts in the chat. I just sharing the Canadian Wildlife Health Cooperative a link. They have an online portal. Anyone can submit a report or a sample for testing. It goes to Guelph, and it's really key. And it doesn't have to be, if you're out there duck hunting and you see a turtle that looks odd, that's a good thing to report. And I think we should have everybody out there with their eyes open and reporting on things.
It's a great point. Okay, Keith, thank you. I'll toss that in the chat as we wrap here. And Sue, over to you for final thoughts, maybe on what's one thing you want people to take away, or one resource you'd like to plug.
Yeah, I echo the thoughts too, but I think as I went on and on about in my talk, it's the public, getting the public behind, and not just official citizen science projects, but the unofficial ones that we have. we're trying to quantify the impact, the conservation impact that our education has. So we have conservation action surveys that people fill out, and they fill out things before a presentation, after a presentation, but then they also go back and then they fill out how many things they did as a result of what we taught them. And that's just individuals, apart from ones that we may have plugged into a group to have a more integrated approach to it. So I really think that is so powerful. We can do what we do, it's save 1,000 turtles a year, but if the 15,000 people save one or spread the word or say, you know, protect a nest or naturalize a shoreline or whatever, that's what's going to really make an impact. But anyway, yeah, we're going to join force, I think, and produce, get more information on our website so that people can have a resource to really tap into what's going on across the province, and you know, get involved in, there'll be an integrated map that hopefully we'll be working on with Parks Canada. So, and our website, ontarioturtle.ca. It's a pretty easy one, but if anyone wants to look up or give us suggestions or feedback, we're happy for that.
Perfect. Okay, thank you both. Well, thank you very much, guys. Appreciate you helping us out with this at the end of the day, and great messages, some nice recurring themes throughout the day. So always nice when it all fits together, of course. So thank you both, and appreciate your time. And on to the wrap up here as we wind down.
Thanks so much. Take care.
Thank you. So just as we close here, just a couple quick things I wanted to highlight. Big thank you to Lauren Tonelli, who's the co-chair of today, and this couldn't have come together without her help and support. But there's also a few people behind the scenes that I wanted to single out just because they're important voices, and they've brought this all together. So Biodiversity Council Chair Steve Hounsell, from Natural Resources and Forestry, we've had Sarah Higginson and Scott Poser and many others. Sorry to shortchange anyone, but very important people in not just today's session, but all of these presentations that have been coming together for the Biodiversity Council's ongoing summit. I did want to, I'd be remiss if I didn't give a quick plug to the next sessions, which are coming up. This is a multi-month affair that's been running, and so mid-September, there's a few really good ones. I'm just hoping I can plug to get on your calendar. In mid-September, I think the date is the 16th, but I'd ask you to check the Biodiversity Council website to confirm. Mainstreaming biodiversity within agriculture, and another corresponding series of webinars. The other one is on mainstreaming biodiversity within forestry sector. So both very important, and just about a week after that, mainstreaming biodiversity within business. So really important conversations, a little bit outside of the scope, I guess, of reducing threats as our topic today, but still very interesting and a very different cluster of speakers. So would encourage you to check those out and register if you're available. If you're not available those dates, these webinars are always recorded and the recordings are circulated, so just something to throw on in the background if you're interested in broadening your perspective and maybe learning a few new things. I just wanted to thank everyone who's tuned in today. We've had kind of a circulating list of attendees. Always appreciate the time. I know it's very busy, especially in the month of August. But again, many people will be viewing this in the future, so just wanted to say thank you again for participating live or as a recorded version. Again, big thank you to the Ontario Biodiversity Council for continuing to support and put on these sessions. All council projects and members are being highlighted, and it's just nice to get the word out a little bit more about some of these shared threats to biodiversity and some of the actions we can take. So all next steps have been recorded today, and we're going to be submitting the outcomes out of this, the calls to action to the Biodiversity Council, to put those all together with previous session lessons learned as well, and compile those towards the end of the session in October. So with that in mind, the hour is late, so thank you very much again for everything today. Great feedback in the questions, so appreciate that very much, and appreciate it, and have a nice day, everyone. So thank you, and keep well.